Good morning, everybody. We're here for the final event of CORALIS, which has been a 4.5-year project on industrial symbiosis. We have a very tight schedule to show off everything that we've done over the last 4.5 years. We are both in this room here at the Comet Meetings Room in Brussels and also online. And we have questions and answers at certain times. We've got an event. The first session is on the technical issues related to CORALIS, and then the second one is on the non-technical. And then we have a really great panel discussion with people who aren't part of the project to talk about industrial symbiosis. But before I go, you see this chair here. There are some prizes. On your chairs, you'll see the chance to win big. Thomas told me he played 5 times yesterday, and so we have to beat that. Okay? And so we have to have that chance. We're in a big period here in Europe. The CORALIS project is an incredibly important part of what we're trying to do in terms of the clean industrial deal, the industrial strategy, our energy and climate objectives overall. You know, this was a 4.5-year project that, you know, the total value was over 22 million euros. That's not nothing. And over 17 came from the European Commission itself. So the individual companies and others put in a lot of effort and financing themselves. So it's quite important. What's important to also know is that there were 29 partners in this. How Marcelino and others organized that is beyond me, okay? I could never do it for 29, but thank God we actually have some people who are really good at doing that. Fantastic. But please come in. We've started already, okay? So I think it's important for us to get a good overall impression of what's going on. We've invited Peter Handley to give a keynote speech. I don't know if you know Peter. I've known Peter for probably 10 years, but mainly by reputation at the beginning. And because he worked in the Secretary General's office at one time, and he was at DG Grow, handling energy-intensive industries like your companies. Quite involved in the whole industrial sector. He is now a senior associate for the Cambridge Institute for Sustainability Leadership. And he's was in the commission for many years, but now he's actually there to keep the momentum going in terms of what we're trying to do in industry. Peter, I'd like to invite you, please.
Thank you for the introduction, Rod, and it's super to be here. I left the Commission at the end of April last year after a long career, and now I'm still interested in what's happening to industry, particularly to energy-intensive industries, to process industries, and I'm very personally committed to a combination of sustainability and resilience, and everything I do tries to fit into that framework. I think the very first thing I would like to say is congratulations. Congratulations on conducting this project, and congratulations on completing it. And what I would like to do is just try and connect your project with the bigger picture, if I may. In the last few weeks, there's been a lot of stuff said about competitiveness. You've had the Draghi report last year, you had the letter report a little bit earlier on the single market, and you had the political guidelines from Ursula von der Leyen. And one of the first things that this new commission produced was the competitiveness compass, showing how it intended to translate what Professor Draghi had recommended into action for this political cycle. And that work has already begun. So the 26th of February, the Commission published the Clean Industrial Deal, which Rod has just referred to, also work on affordable energy, and the first of a number of packages to roll back red tape, the omnibus simplification packages, they're called. And today, actually, something else is happening, which is directly relevant to energy intensive and process industries, particularly those in the metals business, because today the European Commission will publish the steel and metals action plan and the transition pathway developed by the metals sector stakeholders and other stakeholders as well over the past year or so. And this is all to show that energy intensive industries do have a place here in the European Union. There's been far too much deindustrialization over the past few years, and the reasons for that are many, but partly it's due to unaffordable, non-accessible energy, lack of grid connections, the difficulty in procuring enough low carbon or clean energy for industry's needs, difficulties getting enough of this new green or renewable hydrogen to do the business that fossil fuels have done in the past. That's one thing. A second problem has been unfair trade competition, particularly with so much global overcapacity built up by China and stuff coming either in from China or from Chinese companies built in other parts to access the European Union market. So you also see now a much more muscular approach from the European Union towards unfair trade practices and inward investment in the European Union, which is backed up by unfair subsidies. So a lot less naivety is going on. And another area I think of particular relevance on the role of the energy intensive industries is innovation, hence the importance of projects like yours, where you look at research, innovation, new business practices, and how this can contribute to improving energy efficiency and resource efficiency. Okay, so that's a very important part of it as well, the innovation and getting innovation to market here in the European Union. And what I would say is it's never enough to have a nice, shiny R&I project, partly financed by the EU, and have a nice final report which goes on someone's shelf, and you point back to closed demonstrators, right? The key thing has to be how you take this stuff forward, how you scale up, how you deploy across the European single market, and where are the incentives that make that possible. And that's what a lot of the Clean Industrial Deal and the Steel and Metals Action Plan are about. It's about looking for the business case, looking for the regulatory and financial incentives that can drive the demand for doing things in a new way, and also producing the evidence base that can demonstrate, for example, industrial symbiosis is producing quantified benefits in terms of environmental footprint, climate footprint, etc., etc. So I don't really want to go on much more than that, except to say, even if you don't find the words industrial symbiosis explicitly mentioned in any of the documents that I've just mentioned, industrial symbiosis is embedded implicitly at the heart of what needs to be done to reinvigorate energy intensive and process industries and their whole value chains here in the European Union. And if it wasn't enough to have that done through the drivers of decarbonisation and competitiveness, the new driver is now defence and security. Even more than ever before, the European Union institutions and member states are looking at the metals, the chemicals, the other process industries through the prism of economic security and hard security. It's quite clear with all that's going on in the world at the moment, the realignment of big countries and their positions, that this is a standout moment for Europe to show whether it's got what it takes to secure the energy and raw materials needed for its economy, and to maintain and expand those energy intensive industries which are necessary for decarbonisation and competitiveness and our own security. I'll leave it at that point. Thank you very much.
Thank you very much, Peter. Is there anybody with a question for Peter? I have one.
Yeah.
You mentioned the expression financial and regulatory benefits. We met yesterday, and when every time we heard the word regulatory, it was more of a burden than a benefit. Can you give it an inspirational word of how it can be a positive factor? Because I mean, and when we talk about the regulatory issues, we talk about it at the national or even at the local level as well. I mean, the EU can only do so much, but I mean, if you could give us something positive to think about in terms of the regulatory regime or environment.
Yes, well, I would give you three examples. One is financial. It's through regulations that you have these various European funds, like the Research and Innovation Framework programs, like the Innovation Fund, that can be there to finance and give a boost to projects which are trying to do the right thing. So finance and investment, and increasingly the role of the European Investment Bank in coming in to flank and de-risk a lot of these projects. That's the first thing. The second is on stimulating demand for clean, green, well-produced products. And that is where the role of public procurement comes in. And a lot of what's being said in the Clean Industrial Deal and the Steel and Metals Action Plan is about moving away from pure cost criteria in public procurement to introducing criteria around resilience, sustainability, and circularity. So you could very well see, and also minimum recycled content requirements. So you could very well find that the 13% of European GDP, which is driven by public sector procurement, can help to be a pull factor for getting industrial symbiosis through the door. And the third thing I think on the regulatory side, I would say, is it's about the carbon emissions and putting a price on carbon. So the more that you put a price on carbon that drives investments, the easier it will be to do things like your activities, which are driving down the use of energy and capturing much more of the value. Wastes become feedstocks.
Thank you very much. We need to hear that. We're not always so sure, especially, well, we have the next section is with actual demonstration sites, and those demonstration sites actually see all of the foreseen and unforeseen issues and challenges and barriers, and a lot of them are regulatory, and even dealing with permitting issues and that. I mean, that the nuts and bolts of actually doing something on the ground, and that's one of the real benefits of these Horizon projects, to actually do it. And so I think you, in a very short little period. The other thing about CORALIS is that, to follow up with what you were saying, the project ends now, but the concept doesn't end. I mean, and the movement to keep pushing forward and to keep embedding this into the EU's reason for. I mean, you explained all of the reasons, and the current context is very difficult. So that we're dealing with, and we really have to have a new reason for pushing ahead in Europe. There's so many factors that are involved. Also, the other thing is, I just read in one of the papers this morning, is that last year was the warmest year in 800,000 years. And the last 10 years were the warmest 10 years ever, okay? So whether we're working in buildings, whether we're working in industry or transport, we've got a lot of work to do. And I'm sure at the Cambridge Institute for Sustainability Leadership, you'll be giving us that oomph as well. Thank you, Peter, so much.
Thank you, Rob.
Thank you. One of the really good things about CORALIS is, well, one of the absolutely essential things about CORALIS is actually demonstrations and actually doing things to see, does it work, does it not work, with a whole number of partners. This next session is looking at the technical solutions. I mean, we could, sometimes you could say technical frustrations, but that's the whole purpose of CORALIS, is to just keep working away at it and see. And I mean, obviously the context was difficult. You had the pandemic, you know, you had the Ukraine war, which affected the price of natural gas and other things. And so I'd like to bring forward, I have to move Jürgen's. This is going over here. These are the prizes though, okay? These are the prizes you can win. Thomas, have you got past 5 yet?
No.
No?
I was listening carefully to the excellent speech.
I would like to invite Paquita, Daphne, Thomas, and Johannes up here. And they've each got, now I don't know if you're going to want to. I'm glad you're saying that, not me. Okay, so we actually have 3 of the demonstration sites, one in Spain, one in Italy, and one in Sweden. I mean, Sweden is a no-brainer. It's just about tomatoes, and I came from the tomato capital of Canada, so I have a strong feeling. And then we have one representative to look at the followers, the 3 companies that were actually following this whole process. So we'll. There's a microphone there. Oh, who's starting? Oh, Nikita, you're starting.
Is
Now,
it
you've got
working?
15 minutes, okay?
Yeah.
Oh, here, use this.
Is this working? Yeah.
Yeah.
I think this is, no? Okay. Okay. Good morning to everyone. My name is Francisca Galindo. You can call me Paquita. It's more popular in Spain that name. I'm working for Fertiberia, which is a Spanish company, but it's all over Europe. Oh, sorry. And we participate in the CORALIS project with our demonstration in Valle de Escombreras, which is an industrial area where we are seated with our factory of Química del Estroncio. Química del Estroncio is strontium chemist, which is a factory that produces several industrial and fertilizers, as you will see. Our partners in this project is, apart from Fertiberia, who is the leader, is Circe, which is the promoter of this, or the coordinator of this project. Of course, Química del Estroncio, it's one company of our group, and Incro and Ascatet, who are engineering expert in technology. I will forget. Well, Fertiberia is a fertilizer company, mainly, also industrial product, and we are very, very much concerned about sustainability and the decarbonization of our sector. A proof of that is all these projects all over Europe, even in Sweden, for green ammonia project based on green hydrogen, and we are the first in Europe to build a green ammonia plant in Portollano, 20 megawatt of green hydrogen. This is our current asset footprint in Spain and Portugal, but we are also running plants in France, Greece, and Netherlands. Cartagena is the city where we are running this Química del Estroncio factory, and it is located in the southeast of Spain, in the Mediterranean coast, a very dry area, you will see. And of course, we are facing a lot of problems, as you will see. Why CORALIS? First of all, let's see what is the Química del Estroncio production. We are producing strontium salt, mainly nitrates, sulfate, carbonate, for the industrial and technology application. For example, or your laptop has some strontium from our factory or mobile. Every flat screen is using strontium product for filtering of radiation. And But also we are producing fertilizers as calcium, magnesium, ammonium, and potassium nitrate and sulfate. What are the challenges before CORALIS or after CORALIS as well? First of all, in one of our plants, potassium nitrate, the formal plant, we consume a lot of energy, electricity, but also steam in other plants. In this formal plant, we produced some byproduct or side product like ammonia chloride, which is a very difficult product to be marketed. And we faced problems of raw materials, and we were thinking about circular economy and industrial symbiosis. Why not? The water use, as I said, is a necessity in that area because it's very dry. And also we faced a wastewater problem in the cluster, in the area, in the industrial area, because our wastewater has some salt as calcium that producing some problems in the discharge. So this is the Escombrera Valley. And you can see how many companies are surrounding Química del Estroncio, and we thought we could have some collaboration with some of them in a symbiosis project. So before CORALIS, this is the schedule of the production, and we didn't have many symbiosis collaboration with our neighbors. It was nearly standalone production, only purchasing raw materials and selling product. Some collaboration with some of the plants nearby and selling product or sending product to other sites of Fertiberia. Then we started Project CORALIS, and this project for us, the demonstration, pivoted around a new potassium nitrate process. It was patented by Fertiberia, and it is based on moving bed ion exchange. What are the advantages of this process? Reduce needs of water, that's very important in our area. Very, very low energy consumption. There is a byproduct, which is hydrochloric acid, that is reusable as raw material in our factory, and reduce it. I will say there is not wastewater after running the plant, and it's a unique process in Europe. So what are the new raw materials and energy origin for this plant? In circular economy, hydrochloric acid is a byproduct. Calcium can be recovered from calcium to produce calcium nitrate. And there is another byproduct after recovering calcium, which is gypsum, can be recovered also for other of our plants. And in symbiosis, we can use CO2 from one of our neighbors to carbonate, sulfate, and for example, sulfuric acid from another neighbor, and so on, other raw materials or byproducts or side products that our neighbors are producing, we can reuse them in our plant or in our site. And there's also in this CORALIS project a study for producing renewable energy in a CSP plant, for a desalination plant that is close to us, and also energy for us and for the rest of the cluster. So after CORALIS, before finishing the project, what were the CORALIS expectations? As you can see, compared to the previous one, there's a lot of collaboration here with many of the different plant or companies in the area. You can see there's 1, 2, 3, 4, 5, 6, 7 different collaboration, and of course, circular economy inside the factory. Oh, sorry. I won't go very much deep in the details, but there were foreseen challenges and barriers. The foreseen were more related to technical to technical issues, but and also permitting process, lack of available land for the CSP plant in the area, etc. But there were, after starting the project, some unforeseen challenges and barriers. As Rod mentioned, COVID-19 was a very big challenge for us because it produced a long delay. The Ukraine war jeopardized the project because of the high cost of energy and materials. There was other technical issues that could be resolved. For example, designing 2 new pilot plants apart from the main one pilot, because we designed the demo plant, pilot plant for recovering hydrochloric acid concentration, and now 2 new pilot plant to nitrify the wastewater and the hydrochloric acid. But there were other new delays due to equipment and instrumentation market problems, because mainly for COVID and Ukraine war, and what more ever could happen, but happened. Fatal accident during the construction of the plant. It was very, very, very sad. So what were the project phases? First and main, the demo plant design. From this design, the hydrochloric acid plant, pilot plant design, modeling and simulation, permitting process, demo plant construction, and also 2 more pilot plants, all construction of this pilot, commissioning, installation commissioning, sorry, and the pilot plant and the demo plant running a result. So next, you will see some results. For example, from the modeling and simulation, it was done by Circe, and the results were very, very good compared to the real result. Results from the nitrification pilot plant, we tested 2 different novel processes, one based on catalyst with not very good result, but another one based on a new biotechnology treatment for very high salinity with water, and it was the result was very. Okay, yes, I'm finished. These are the results from the hydrochloric acid concentration plant, also a novel process, and the results we are still working on them because there are some problems with filtration, but the results are not bad. We got a concentration of 27% of hydrochloric acid. These are the results of the demo plant. We face some problem, but the main result are very good energy consumption, very low, very good ion control with novel selective electrodes, and so on, a reduction of water consumption of 50% and no wastewater at all. Sorry. And this is my last slide with main conclusions. I divided my conclusion in 3 levels: energy and emission. The reduction has been very important, more than 3 times the consumption of energy compared to the formal plant. The same for CO2 emission. But the study of the CSP plant was not positive because of the lack of land in the surrounding area. So we have to go studying this project because it's very good for the area. It's a very sunny area, and we have to find the right location. Symbiosis, a very good result from the pilot plant to reuse byproducts or side products from neighbors. For example, hydrochloric acid concentration by product got is 27%. The use of other byproducts from other neighbors for the bio treatment also successful. And the recovery of calcium from the wastewater is also successful, so we can resolve the common problem of clogging in the industrial cluster. And finally, for circular economy, we've got very good positive result for the carbonation of gypsum using CO2 from neighbors and recycling the product, calcium carbonate, as raw material. Also very good result for the hydrochloric acid to be reused inside the site. And the only problem will be the gypsum. We didn't get the right specification, but we are working on that. And this is my last slide. Thank you very much.
Perfect. Thank you so much. Well, we're going to have a little question and answer session after the 4 presentations. So keep thinking about it. But let's just have a look. Now we'll move from Spain to Italy, to Daphne.
So good morning, everyone. I am Daphne Mirabile from Centro Sviluppo Materiale. This is a legal entity of Rina Consulting. And I made a facilitator for the demo case of Brescia. Here you can see the geographical place of this demo case with the 4 participants. We have aluminum producer that is a rough metal. Then we have cast iron producer that is Sponderie Torbole, and then we have 2 steelwork that are Orimarten and Feralpi. In this case, you can see the different exchange, but we can talk later about it. So, why we participate to CORALIS? The most important thing for us was to reduce the quantity of material that every year is disposed and that have a value that can be used. So the idea was to reintroduce in the value chain as much as possible metal residue to create synergy and prevent landfilling, and to understand how it's possible to create symbiosis in this sector, and also to find something that is environmental friendly and can reduce CO2 emission. So what we have achieved is a more deep understanding of new process. We have set a process for the recovery of metal residue, and we faced a lot of problems connecting with the legal authorization either to circulate waste. And we understand also better the social acceptance of everything that we done for a more sustainable company, and circulation also of material, not only in Italy, but also abroad. Yeah, I quickly speak about the result, the main result that we obtain. We start with the technology that is well known, the briquetting of material. And here in this CORALIS project, we use the briquette to recover iron, to produce ferroalloy, and to reduce metal oxide to obtain a byproduct that can be used in different processes. This technology is already known, but is not so much analyzed and studied for these 3 cases. We had the possibility to work together with the University of Brescia that prepared a model of this industrial symbiosis. This model is considered an hypothesis because all the number that we used are the potential possibility of exchange of material, energy, and so on. And then we try to analyze as much as possible a completely new process that regard a material that is named fluff, and there is a organic material arising from the waste used by rough metal and to recover aluminum. This process has been analyzed at laboratory and pilot plant scale, but we had a lot of problems from the authorization point of view due to the novelty of the process and also for the generation of a high quantity of energy and potentially dangerous emission that have to be analyzed more in detail. Then at Torbole, a new process has been set up to separate metal residua from silica that are generated during the standard process of sandblasting. And this give a lot of good results. So in the future, probably this will be an industrial process. And finally, also with the use of, with the support of University of Brescia, we have analyzed the utilization of slag in different sectors, not only the standard one that can be, for example, the cemetery, and also the waste heat recovery when the heat it's very high or when we have a small flow. This is more or less the consortium. As we can see, we have 4 participants from the industrial sector. Then we had a local facilitator that support the company for the permission authorization in the exchange of material and the setup a new process. Then we had the University of Brescia that supported us to the modeling and analyzing the potential of industrial symbiosis. And finally, Rina was the facilitator of this industrial symbiosis case. So what's the future? And what we have learned during CORALIS. One of the most important things is that the company that will be together in symbiosis have to have a RTL level more or less same between the company, because when you have too much difference between the RTL level, it's difficult to manage the quantity of material or to have a standard process. At the moment, we reached only micro-industrial symbiosis. So in the future, the idea is to upgrade to a meso-industrial symbiosis system. And in some cases, this is the result that we obtain are very promising. And concerning the CO2 emission, this was not our first objective. Anyway, it was considered in all the steps that we have done. In particular, one of the activity was concentrated on the use of biochar. And in this sense, we had 2 main problems. One was from the technological point of view, that the biochar is not a good carbonizing agent in melting process. And the other one was related to the authorization ether, because you can, at the final point of the project, we can use only commercial product and not biochar that is considered a residue from other process. And regarding the not technical point of view, the most important was the permitting process status for experimentation. Process need more than 1 year. And for a real industrial process, we can reach also 5 years. That is too much. And another point is even at national level, we receive the European legislation, and this is received also by local entity. At the end, we have to face 2 or 3 persons, and if you have not the right person in front of you, or if you have not created the right trust between them, the procedure can be more slow than respect. And finally, the industrial symbiosis is a very important point that has a lot of aspects, technical and non-technical. And even if a company desires to participate to industrial symbiosis, they need a financial support that can be at national level or at European level. And this can be obtained a lot of results that can be shared and discussed together to find a real solution. So this is very important for upgrading the industrial symbiosis. And this is all from my side.
Quite a different situation than from Spain, but very fascinating as well. But Peter, you also noticed some of the regulatory issues they had, okay? Next, I'd like to bring forward our Swedish colleague with his tomatoes, okay? Thomas.
Thank you very much. And happy to be here. Oh, yeah. This is a little different. So I'm going to talk about the demonstrator in Sweden. It all started with, well, there was a need for a demonstrator in Northern Europe for this project, and some folks at Thielthe and someone in the commission made a leap of faith and decided that 2 people in a startup in Malmö would deliver on this. Somehow. So ta-da, there it is. So whoever made that decision at the commission can sleep a little easier because it actually panned out. This is what happened and compared to objectives. So there she is, 10 hectares of greenhouse producing about a little under 10% of the tomatoes in Sweden. Right now, all of the domestically produced tomatoes, because it's the only one using lighting. This year, 100 good, sustainable, decent jobs created. It's using waste heat for about 85% of the heating need. The heating need of a greenhouse is very volatile. So you can never cover, or you can, but it's difficult to cover all of the heating need with the waste heat. So there are heat pumps and other systems to work with the rest. It is not, which was promised, recycling CO2 from flue gases. And part of the reason why is that a conventional greenhouse, which this to a large extent is, opens the windows usually like twice a day to get rid of the humidity. So around 80 to 90% of the CO2 you add is wasted. So can anyone here, show of hands, can anyone spot the flaw in terms of industrial symbiosis? There we go. Everyone with a hand up has qualified for the practitioner course offered by Linköping University in industrial symbiosis and the engineering of it. Because yes, that and we have to all admit we all applied for this and felt that was a good idea at the time. So that shows that we learned. What we did do is validate a business model for this. This brave person at the commission invested 5 million euros, of which a good chunk of that went to researching and following the project. we have invested 120 million euros into this greenhouse, or not we, but we have, by showing a business case to investors, attracted that amount of investment. So good leverage on that decision, I would say. And it is, this whole process has been open to research and visits throughout. So we're very happy for that. There they are, aren't they beautiful? So a little bit about how this is done and how it's built up from the technical to the financial. And there are 7 points there on the left, way too heavy for a first date. So I'm going to point to the 3-point model on the right. And the key thing here that was actually fundamental to the CORALIS project was the physical modeling that needs to underlie the business model. And in this case, we arrived at the physical model needs to have an hourly granularity. So this is where the hard work goes in, to show that there is a symbiosis flow and that flow creates value. That's what you build on. And as Peter was saying, some of that value is created by the legislative frameworks, which have changed in our favor during the CORALIS project, I should say. Yes, so it needs to be built. How many people here have done a business model or see business models often on a daily basis? Yeah, a few more than were brave enough to answer about the CO2. So everyone that I've seen starts with a page that says assumptions. And assumptions is like the economist's way of talking about the real world, like physical flows and that sort of thing. And my background is engineering physics. To me, that's the real world. The rest is you assume that you can make a business out of it. But that's I'm being petty here. But the important point is that you cannot assume that a physical flow, and you cannot put pretend that variables are constants, or that linear connections or that nonlinear connections are linear. So the physical model is going to be a lot more intricate and varying than the overlying business model. And then what you need to do is, when you build the physical model and start building your business model on that, you start working also on the business terms between the parties. And these all need to hang together, because you have to show that you're creating a value with a physical flow. But then, of course, you need to agree on how to share that value and make sure that you don't destroy that value in fulfilling the various other business terms, because there will be issues of security and safety, data exchange, and all this that we've shown in the project. And these tend to sort of eat away at the business value. So you need to have that model and know that you keep going back to, no, this is what we're doing. This is the flow we're working around. So there it is. Now you all know. Now you can all go out and do it. It's that simple, actually. Just a few, looking forward, a few observations of what's from our perspective at WARM, what is going on now. And one is, and I did not see this coming, is that we have somehow set a standard for AI. And how that happened from growing tomatoes, it's not really a long story. The thing is that we showed that you can recycle 45-degree heat profitably. And that's too low for conventional data centers, but what's happening right now is a move into AI, new chips, new technology, and they can move up a bit in cooling. And so suddenly the new normal is to get local acceptance to build your data center. you have to build a greenhouse. So you don't have to, but it's a major benefit in terms of the, NIMBY permitting issues to show up with a greenhouse as well for many. We also see that the work we did on trying to recycle the CO2, again, it was wasteful, but also it was very small amounts for the greenhouse. If we were less wasteful in the greenhouse, it still would not pan out as a business case because it was just to be too little CO2 because of diseconomies of scale. But what we see now, and this is very much pushed by recent EU legislation, is that we will there's a large push towards CCU, CCS, and then there will be systems built where you will try to recycle all the CO2 from pulp and paper mills and have a variety of symbiotic activities on site, and some things will be transported. And a lot of that will be around food, feed, fuel, simple hydrocarbons. And so we see a lot going on there. And lastly, something that we're looking hard at is that we've realized that aquaculture, especially warm water species in Northern Europe, is a good symbiosis case for low temperature waste heat. And I'll stop there. Thank you very much. Oh, here. Okay.
Thank you, Thomas. Keep thinking. We've got one more presentation, and I want you to give us some of your views as well. Next, we're going to go. We've had the 3 demonstration hubs, but now we're actually going to discuss the followers because of the way the program is designed. So I think, Johannes, I think it's really important to hear what you've got to say about the 3. You represent one of them, I believe.
Oh, I'm going to try to represent
all 3.
all 3.
Well, you work in one of them.
Exactly.
Yeah.
Thanks a lot. Thanks for the kind introduction, Rod. Okay, I'm trying whether this is going to move.
You have to press towards it.
All right, here we go. A very warm good morning. Thanks for the introduction. My name is Johannes Lindhofer. I'm working for the Energy Institute at Johannes Kepler University in Linz, Austria. So I'm representing a research organization. And I will present also the views from the follower cases in that sense. Yeah, here it goes. I will start with an apology on this slide because it looks a bit messy. But anyway, you see, there has been a lot of partners pulled together in 3 cases, and that's how it is. Everybody has his own agenda. Everybody needs to produce. Everybody needs to run their facilities. We have really front runners in their field pulled together in the 3 followers and thought of, okay, how can we progress towards industrial symbiosis? The slides are moving, then we will. Here we go. Thanks a lot. Okay, so we are at a very early stage of industrial symbiosis at the 3 follower cases. We pulled together the relevant actors. One case was located in Basauri in Spain, which dealt with the energy recovery from steel production. So you have a large amount of waste heat from electric arc furnace and the whole steel shop, which is hardly utilized at the moment. So the target was really to develop and investigate in thermal recovery and storage systems to reduce consumption and share heat, potentially by nearby industries or other recipients. The second case, where I'm coming from, is in Linz, Austria. So we have there a big steel mill, fence to an ammonia production plant. Both of them will use in the future the champagne, what we call the champagne of the energy transition. It's renewable hydrogen. For that, we needed to find out, okay, what is the best way to supply them with that new asset? The third case is in the refinery sector in Turkey. So in Izmit, there's not just the refining of crude oil. You just not refine the crude oil there. You also need auxiliary material for this, which is caustic soda, and it's spent. So what to do with the waste that appearing there from desulfurization? So there are a lot of challenges. And what we did in the project is really to come up with to evaluate options, what to do best within the three cases. But why did we do that? It's quite clear. The drivers are pretty much the same. All over those heavy industries, all over those production sites have the same decarbonization and circular economy goals. Peter really perfectly pointed it out. But on the other hand, we still need to secure economic and operational efficiency. And there are some hurdles to overcome in the regulatory compliance and policy alignment, which we heard in each and every meeting of CORALIS. It's already kind of a sound in my ears. I have some issues with this. Here we go. I would like just very briefly point out major results and achievements. So in the first half of the project, we really focused on the technical and economic assessment of options for each and every follower. So for the steel shop in Basauri on the thermal energy recovery, there was been conducted a technoeconomic analysis for an energy recovery system there. At Linz, we had a strong look at what renewable hydrogen production options do we have, locally on-site, but also importing, and how can we manage gas exchange there to identify viable business models and options. And in Turkey, at Izmit, a feasibility study for the refinery spent caustic reuse in industrial symbiosis have been conducted. In the second half of the project, we moved from these technical economic evaluations towards the next steps for really bringing industrial symbiosis into life locally. One major effort has been taken on stakeholder mobilization and engagement activities. So local entities, but also the whole project itself supported the local actors, and we at our institutions developed individual roadmaps for implementation. So coming from a vision towards actionable, implementable points along a timeline of around 5 years, what to do next at the specific sites. Keeping, let's say, the evolution, what has been the major role of ourselves, but also of the local supporting entities. We call ourselves facilitator, and it's quite relevant for the evolution of the ecosystem of industrial symbiosis in my point of view. Looking at coordinating the relevant stakeholder, who is potentially supporting our endeavor, who is a potential opponent. We need to identify them and also serve their needs. We support it in implementation. That's pretty much more the technical or decision-making straightforward process, but also in terms of overcoming barriers, trying to navigate these regulatory challenges out there. So there was always a local support in the local language with, let's say, trust-building mechanisms. People know each other. But there was also this overall stakeholder engagement and road mapping from the CORALIS project, pretty much more centralized by our institution. What's next? We can say, okay, some key barriers are still out there, and especially the regulatory barriers persist. Material reclassification, if we take the example of Turkey, we have certain specifications of the spent caustic. Who is going to take it? It's a waste. How can we reclassify it? We have some infrastructure limitations. You can imagine if you want to share hydrogen or if you want to build CO2 pipelines, who is going to own them? Who is going to finance them? Is it a public good or whatever? And there is for sure financial uncertainty as well in terms of not a lot of that has been demonstrated. Thanks to the demo cases, we have learnings, but they are all very specific as well. And then for sure, okay, it's always an additional effort to get all the stakeholders on board and provide the right governance. So some new opportunities that we think that are quite relevant, that, for example, hydrogen and CO2-based industrial symbiosis, waste to energy and chemical recycling are really top technologies that needs to be demonstrated and that also would serve industrial symbiosis and especially reduce the dependency, so can be done more locally at the industrial sites and the hubs. That is pretty much also aligned with the decarbonization, carbon capture utilization, and to speed up the process, these digital technologies could really act as an enabler to be a bit faster via digital twins to simulate, to test business models, not just via Excel spreadsheets, to do it a bit more, let's say, 2025 like. With that, I would like to thank you for your attention on the follower cases.
Johannes, thank you very much. This is a shock today because I warned these four about how pressing the time is. They're ahead of time. Okay, they actually, I have to congratulate all four of you. Demonstrations play an incredibly important role because in the innovation phase, I mean, it's to demonstrate, to convince people inside of the companies that are involved that it made sense to do it, but it's also to be able to explain to people outside of your little community, whether it's in your country, whether it's in Italy or Spain or whatever, to a wider audience of the benefits from it. I'd like to ask, I'll be here, but this is going to be on. I'd like to know how senior management reacted to this. I mean, did they find this 4.5 years a real success or a burden themselves, like just from an organizational sense, that or would they say, forget it, this is too much, or did they really get off on it?
Oh, there were several stages. The first, exciting about the project. The second, fears, mainly when the all unforeseen barriers or problems came. Then courage, let's go on. And now it's a little bit relaxed about the result. So these are the main stages.
You showed good
project.
results, though. You know, the results were quite good.
Yes, in general, they've been good, and some problems can be resolved. So we will continue working on the project and to improve the result and improve the collaboration. This is very important.
And Daphne, what do you see on this?
Well, from a technical point of view, I have seen that the company are very open to collaborate and to find a common way to resolve a common problem, or also to face new problem and process. So even if there is not a big project that can help a company, I see in my daily work that they are making small symbiosis events or contact with other small company to resolve environmental problem. But anyway, we have a not technical barrier. Also, the social acceptance is very good for industrial symbiosis, but from legal point of view or governance point of view, sometimes it's too slow. So when you finally resolve a problem and you finally can start the process, then probably your technology have to move up and you need new authorization. So this is frustrating sometimes.
But I mean, it should be, for the different companies that are participating, it should be a win-win situation. If some companies losing, they're going to leave. They're just not going to participate. And so how do you keep everybody on board?
In a big situation, you need a facilitator, a local company that help you in organize everything. But when you have not a so big group, you can arrange.
So did Rita play the role of the facilitator?
Yes,
Yes.
in this case, yes.
Now, in your case, who played the facilitator? Because it was the company, but it was also facility.
Yes, the mother company was the
And
facilitator.
Thomas, I presume that your company, Warm, was the facilitator. Or
Yeah, exactly. So the senior management is on Warm was all on board because I'm the chairman of the board. So if they,
Oh, but
but
the
yeah.
companies that were involved in the building of the greenhouse and all of the, how did they react?
Yeah, I think that all our interactions with major industry is that there's great enthusiasm in the sort of sustainability department, and that can more or less filter over to like the CEO if he or she ever hears about it. But the trick is, of course, to pass the CFO. And there you need to show the sort of the business model. But the big hurdle is the plant manager, because symbiosis really makes, I was going to say his or hers, almost always a he. No, actually it was a her in a while. His or her life just is much more difficult with symbiosis, and there's really no upside, because they probably have some bonus scheme. There's no industrial symbiosis is not a concept in that, right? So it just makes it's risk and more difficult. They might like it personally, but
So why did they go ahead with it then? I mean, did you just charm her?
Yes. Con man. No, I think that there was we started on a corporate level, or mostly do in the companies we interact with, and just create enough momentum so the plant manager has to sort of grumpily go along.
Okay. Johannes, I mean, you played a very strange role in having to sort of explain for three different followers. I mean, you were up in Linz, and I don't know how closely you followed the other two. But what I'm also interested, if you were how much you even followed these three in terms of the ongoing interaction and the lessons learned from them.
Yeah, thank you for that question. I mean, we really kind of followed. You have a lot of meetings, you have exchange within that perfect setup structure of the project, because it's very kind of structured as you need to follow the project, and then you really gain these insights in terms of problems that are kind of pretty much replicating as well. As we saw, okay, on the material valorization and technical issues and so on. And so you really try to transfer those learnings towards the individual cases. So that has been really pretty much on our agenda, and also to kind of, to try to replicate what has been done there at other sites. But also you have certain borders for this, because we've seen, as represented, as I tried to present, the cases are totally different, and you really need to to tailor it to the very specific case. Otherwise, it stays a bit fluffy and not so dedicated. And then you cannot probably mobilize the relevant stakeholders because, hey, this is probably not our business.
But of those three followers, I mean, I don't even know what it means to follow. Did they actually implement? Did they actually talk to companies next to them and try to develop a whole?
Yeah, for sure, for
periodic-
sure. For example, I can give what I've experienced in Linz. So we had during the project close to 20 meetings with the industrial players there, and we more or less always presented an agenda. We always presented cases. We always tried to calculate and elaborate. Okay, what are the options that we have on the table? Please discuss it. And with that sort of action, we really built trust among the players, and especially the technicians from one side of the fence to the other side of the fence now know each other. They can just call them and say, hey, what is your topic on this? And what is your opinion? And I think that is a big gain already.
Did any one of you three ever talk to people, whether it's Spain, whether it's Italy, or whether it's Sweden? You've got three of the strongest national energy agencies that are doing a lot in all sectors, and they are under incredible pressure now to meet the goals of the EU in terms of long-term climate. Did you ever talk to them, or did they ever come to you? I mean, how do we develop a relationship with them? Because they play they want to play an incredibly bigger role. Also, all your countries, there's a new coalition of financial institutions being set up, and they're going to be. The previous coalition was done at the EU level. Now they're actually going to be having national hubs. So they'll be doing it at the national level. I'm just wondering what interaction you've had, because I'm trying to see how these demonstrations get known and better, appreciated.
We talked to the local or regional administration. They came to us. We presented the CORALIS project. They were very happy with the project. They said, this is the kind of project we need in this region. After that, they do nothing. Even for the permitting, we couldn't have some aid from them. So yes, they are very good words. Nothing after that. For the CSP plant, for the example, even the desalination plant is owned by the regional administration. They need the energy. They need the cheap energy because desalination plant, they consume a lot of energy and it's very expensive, mainly based on natural gas. So that could be a very good solution for them. But even to get land, because we don't have, and most of the land belong to the local and regional administration, nobody facilitates this project. But we are very happy, and we will still continue working and trying to get their help or aid to proceed with the project, because we believe in that project.
Thomas wants to.
Yeah, I have a similar experience that we have a great interaction with Energimyndigheten, as they're called in Sweden, and they're very enthusiastic and happy that we do what we do. But when we try to find a grants or something, it just never fits. And in the beginning, this was quite frustrating to me. But then after a while, I started thinking, well, for them to get a budget for a certain call, and someone in the administrative system needs to 5 years earlier think that, oh, this is what we're going to need, and then propose that. It goes up into a budget all the way up to Parliament, and then it filters down again, and then they issue the call. And by that time we're long gone. for better or worse. So I think this actually points to one of the great things about this project was that it allowed us to do the work that we've done in this, which is, I haven't seen opportunity for that in the local innovation or energy systems in Sweden. So I think it's just so important for us and for continued work that there are calls and grants available so you can get things like this rolling that are a little more general.
Are there any questions from the audience? Because I have a question for the audience. Oh, well, for one, because we had Circe running this. I'd like to hear from either Marcelino or Ignacio on this aspect of the technical solutions and the demonstrations and what your impression overall. I mean, you've slogged away for 4.5 years on this. And I'd just like to get, I know, Ignacio, you're coming in at the end, but you're going to be looking at the whole picture. Just on this right now.
This is a tricky question. Thank you.
That's my rule.
Well, first of all, it's amazing how differently the 4 different speakers experience different situations. But one thing was, I think, very similar to each other was the determination of finding a solution, a practical solution at demonstration level. And this is, in my opinion, one of the assets of this project is demonstration. And then we have many things to say at the end of the road, right? And this implies we have lessons learned that we are presenting today, but not only for us, also for their ecosystems. And this is, in my opinion, very, very remarkable. They have many things to be said. They have a storytelling, they have credibility, and they have experience to be shown. And this is not just technical things. They have figures, they have technical results, they have products. But on top of that, they have something to tell. They have business cases that are very promising. And right now, all of them are exploring how to replicate them all. Right. And this is also a key conclusion, a key outcome, in my opinion, is now is the future. Let's put it this way, because they have learned not only from technical, but also from the non-technical perspective. And we will go through this, the second part of the session today.
Great. Thank you. Oh, I got it. I have a question for Peter. What have you learned from these people? Okay.
I've learned that a lot of what you're doing is about capturing waste heat and finding uses for it. And there is going to be a big push on that in the coming months. That's announced in the Steel and Metals Action Plan today, trying to get much more incentives to capture this waste heat, whether it's high temperature or lower temperature. I was very interested to hear about the unforeseen consequences of running a demonstration in one place that you discover a value in another place. The other thing I would say is on the role of public authorities. It's quite worrying to hear that you get a sort of pat on the back at the beginning and good stuff, carry on, but the concrete help is not there when you need it. What I can say from my experience working on the Critical Raw Materials Act is that the role of member states at national and regional and local levels is crucial. For example, we're trying to speed up the whole permitting process, digital by default, single points of contact, integrating the industrial and the environmental dimensions of permitting, and also locking in the judicial review in case you get complaints and appeals. So making everything prioritized. And that angle of speeding up permitting is a very horizontal priority for the EU at the moment. It's in the Net Zero Industry Act, Critical Raw Materials Act, it's in the Clean Industrial Act. It's going to be done for the energy intensive industries specifically that are not net zero industry in the decarbonisation accelerator coming later this year. So my suggestion is the termination of your project is very timely because you now can inject the lessons learned and the things that are needed into this year's industrial decarbonisation accelerator and the rethink about the state aid regimes and how these can facilitate public support, as well as into next year's Circular Economy Act, which is designed to really get rid of all these blockages in the single market for waste, to really make the wastes classification, end of life, the way things work from one plant to another, make these things more fluid and get more interaction between different industrial actors.
So how can they get the messaging across? I mean, should we be producing something for the ITRA committee in European Parliament or the Environment Committee? I mean, how do we get that messaging to the people you're talking about, to the commission or whatever? What do you think is the most effective? We're not going to give them a 150-page report.
No, you don't need a 150-page report, but what you do need is a communication outreach plan at the termination of this project. You need to identify who are the key people who you want to influence, right? You want some industrial champions. Think about the CEOs who are part of this Antwerp Declaration platform,
Right.
for example. Think about the metals sectors who are going to be reacting today to what the Commission is producing for them. Think about reaching in to the key decision makers in the European Commission at political level, right? You have a product now, and you see what works and you see what doesn't work, and you can sell this as a contribution to the competitiveness agenda, competitiveness and decarbonization agenda.
We needed those words. Thank you so much. Now, in terms of these demonstrators, how many were large companies? Were there SMEs involved at all? Or were they all large companies? Were the SMEs, and was there a difference in their attitude towards them? Or were you just, because when you showed that picture of the harbor and all of the different, were all those big companies or were they any SMEs?
Most of them are big companies, Enagas, Repsol, and others are
Repsol.
part of big companies. Iberdrola, for example, another big company. So there are big companies and a smaller one, but it's good to work with any kind of companies. All of them can be good partners. Even smaller companies are better for working with them because they are very active. The results are very important for them because are not so diluted as in a big company as Repsol. For them, 1,000 tons of CO2 are nothing compared to all the production, and things like that are easy to, with all the bureaucracy. And if you talk to the owner of the company, it's easier than to talk to the director of the factory that had to go to the upper level of management. So for us, it's even better to talk to smaller companies.
But the smaller company has a bigger problem going to a bank to get financing, doesn't
That's
it?
why it's better to go for aid from some or part of the financing, aid from administration or European project, etc.
Now, Daphne, you had the diagram showing of all the companies that were involved. Were some of them SMEs or were they all large, or what was it? And what was their different? Was there a different reaction from the difference because of the size? Or
Well, at the time of the proposal submission, Confindustria Brescia made a day together with a lot of company, small, medium, and large, and ask their intention to participate to a project. And the problem for the proposal was to select the right company, because a lot of company like to participate in some activity like this. And then the first thing was to integrate and to find a similar solution that could be useful for the metal sector. But even during the project, we had a lot of question about how can we come into an industrial symbiosis. So obviously there is an interest. For small company is more difficult with the financial part of view, and also for the administration point of view to organize everything. And sometimes a small company doesn't have the possibility to make laboratory testing because they don't have laboratory testing. They have the problem for the valorization of waste, but they don't have the possibility to make some activity related to a project. So when you find a solution that could be useful for them, then they are very interested in to participate something.
Johannes, you talked about your project just in Linz in Upper Austria, and you had many meetings and things like that. Were this combined both large and medium-sized companies?
No, there were just the big two players basically. And what I would like to comment is that a very good thing about it was that they are not competitors at all. So they are working in totally different sectors, and that was a definite benefit. So yeah, and I think it was really also tailored to what was asked for the project, right? So it was addressing heavy industries. And just feel like one small comment on this was, it seems, okay, some of the followers probably partly do not fully materialized in terms of putting something into steel and concrete, but I can probably give one example. There is, in terms of learnings, other learnings, we have an electrolyzer being running by voestalpine, the steel company, with 6 megawatt hours there in another UU project. When CORALIS come into place, the neighboring company, Lat Nitrogen, grabbed the information also from that experience and now sized a 60 megawatt electrolyzer, so the 10th of the capacity of the neighboring electrolyzer, that applied for innovation fund and won this. And so there has been an engineering knowledge and exchange between the two companies, which is also can be looked at industrial symbiosis as well. So knowledge sharing, not just about resources.
Thank you. I'm going to take that as I'm giving you each 1 minute to give your final message or lesson. Johannes, I'll take it as if that was yours. So, Thomas.
Well, I can go on combined with the SME question there, because what we see is in what we do at WARM, we work with a big industry in one end, and then we find someone new to make use of a waste stream, whatever it is. And that company is often a startup. In fact, in the tomato greenhouse, we had to run around and create the company to interact with. But I wouldn't recommend that. They're both so very different types of entities, the two. And one way that we address that difficulty of sort of very different entities working together is that we create a company in between an SPV so that we can draw up all the business agreements with a central unit, because so they don't, I mean, they can meet each other, but the legal interaction is with a central entity that is under our control. And that's one thing. And they're also, not only different in size and age, but also work in completely different sectors, right? So you have pulp and paper, and then you have a tomato grower, with, in this case, they have a business in Ukraine and Kazakhstan, or Dutch. So, they wouldn't, meet for lunch normally. There's a lot of translation, not just linguistically, but culturally between them. And I think that to be able to circulate all the flows that we want to, we will have to work across sectors, which is difficult for all of us, including the EU, which excludes agriculture from anything industrial for historical reasons we all know. But it's just things like that makes things difficult, and you need people or facilitators or whatever you want to call it that can sort of navigate that difference in terrain.
Daphne, your final word on you'd like to impart to all of us on your project, your hub.
Well, I'm sure that the collaboration between the different company will not finish with CORALIS. on the opposite, CORALIS has made some results that show the possibility to continue to cooperate in a different way, not only related to the valorization of waste, but also to emphasize the reuse of heat or to find a common solution for one problem. So I'm sure that this will be not only related to the Brescia demo case, but also to other companies, and to find a new byproduct that could be reused inside company or sold.
We've got 1 minute left. Paquita, you get the final word.
Well, just to say that with this project, we have demonstrated that collaborating with other companies or collaborating inside a cluster between among companies can be a very good solution for many problems of in common. So my point is before starting the project, think about your neighbors. That's my point, because symbiosis works very well locally, more than thinking on 100 kilometers far company. It's better to think about your local neighbors that can have similar problems and similar ambitions. So the collaboration is very good for all of us.
Excellent. Thank you so much. Look at, we've talked about the technical solutions, but I mean, even every one of the speakers before brought up non-technical issues. I mean, you can't not, okay? So and quite a bit of CORALIS was spent looking at the non-technical issues. We've got 3 of the speakers that will raise different parts of the issues related to this, because we're not going to succeed with industrial symbiosis without solving these, or without addressing it. Solving them, you're just addressing them. You're not going to solve them. But it's just like Paquita was saying earlier, there's expected challenges and there's unexpected. And so we have to be ready for all of it. Ignacio, I'd like you to start, please. This little, and you've got 15 minutes, as you know.
Good morning. Before starting, I just wanted to recap a bit how we started the CORALIS project, because it's, in my opinion, it's important to highlight. If you allow me, when we designed the project, we wanted to have, using the EU jargon terminology, an innovation action plus a CSA combined. And then this is important because at the beginning, when we thought of CORALIS, we considered equally important technical, economic, and managerial. And this is part of the beauty and part of the challenge of CORALIS, and I wanted to point this out before moving in. And also taking advantage of what of the nice introduction, what we are going to see now is also not only the elements we have been facing in terms of economic and managerial, but also we have tried intensively to set up tools to support the demonstration cases, how to improve, how to monitor, how to set up new concepts, new business cases. And this is also part of the results, not only the demonstration activities, but also the tangible examples, methodologies, references that have been created along the project. And we have plenty. And many of the things that are going to be presented here right now in this part of the session are public. And this is very important as well. It is also very relevant for us, but also to disseminate what has been achieved, because there are products, are tools, are methodologies that are available for whoever is interested in promoting and flourishing industrial symbiosis cases. Then that said, I will start with my quick 10 minutes in a presentation. And again, also before starting, the title might be misleading, because I just said that these non-technical issues that I'm going to talk, and in the text it is said techno as well. And then this doesn't mean that I'm not talking about something that is not technical, but of course we do use technical data from the demonstration cases. And again, I will come back to this point because we rely on the data coming from the demonstration cases, and we wanted them to actively participate in anything that is developed as part of the CORALIS results. In other words, validation is also very important, and the other speakers of this part of the session will talk about that. Validation of whatever we have produced. And this is also very important, not only because it's a theory, it's not only paper, but it's also fed by the inputs from the industries. And this is what makes this, I would say, more interesting to be used later on and further. This one? I will do that. Okay, anyway. Okay, then I will start with something that has been mentioned several times, which is the role of facilitator. One of the things that we have learned largely is when talking about industrial symbiosis, we start by the technical issues. Everyone feels comfortable about the technicalities of your project. But the more you talk, the more you realize that it's not only the technical thing that you need to face in terms of industrial symbiosis. And for that, we need someone who is skilled, who is able, who is trained, who is recognized by the whole ecosystem to support you in this matter. And this is what we have promoted from the very beginning in CORALIS, the role of facilitator as a supporting tool. Johannes also pointed out before how the different followers have been in contact with the different participants in each of the mentioned ecosystems, but also it's not only how they support the facilitators, they also control the information. They know who is doing what. And this is a very important information because it's the memory of the industrial symbiosis case. To store whatever is happening, whatever has happened in the past might change a decision to be taken in the future. Then this is also another important point. The facilitator is the memory of the environment. And the memory implies that it's not only important for the time that the project is happening. Once the CORALIS project is coming to an end, the facilitator has stored in his or her brain a lot of information for the future. Then it's also another added value, in our opinion, that has been promoted also in the project. And then collection of information, collection of data is also part of the roles of the facilitator that we have promoted in the project. Through this individual, we have been able to gain a lot of information because it's a trustful and it's a trustful information. Is someone that facilitates the dialogue and communicate with everybody in the study and in any activity of the project. And it is instrumental to have this entity or this individual coordinating the exchange of data. And this is how we have promoted all along the project. And we will see how we have benefited from this role in different activities of the project. Then among different tools we have created for the sake of coordination and evaluation framework of industrial symbiosis, different tools. Again, everything is available. Well, at least my part is completely available. And then we have developed different tools to follow up, to measure, and to try to understand where we were, where we are, and where we want to go in terms of industrial symbiosis. Again, using this triangle, TRL, technology, MRL, managerial, and ERL, economic. Also, one of the points that has been largely accepted is the fact that risk management is key in terms of industrial symbiosis. We have heard that from the previous speakers, and we have also implemented one of potential solution based on other cases from the manufacturing sector that has been validated and implemented. Everything, again, is available. I will not go through into this, just to advertise that those tools are also in place. One of the key elements that we have evaluated is how we can support the assessment of the ongoing deployment demo cases in CORALIS and beyond. And for that, we have carried out several technoeconomic evaluations for each of the lighthouses. And we have ended up finding different, I would say, mindsets. And this is what we wanted to promote, to take into consideration different streams that could be valuable, that could be valorized, and how to account them into the overall assessment. And this is very important for us, for the lessons learned. One example, I'm just taking the liberty of introducing what we have concluded in the case of Escombreras, in Fertiveria's demo case. Then we have enriched the scope of the analysis by integrating and by quantifying the economical value of waste streams. And then it enlarges also the scope as well as the analysis for the sake of the evaluation in the future, to plan and to define new scenarios that might really flourish in the future in the industrial ecosystem that we are talking. And of course, those elements would hopefully facilitate the decision-making process in the future within the companies. Then, to sum up with this, we do encourage to carry out such an example and such an analysis in any industrial symbiosis case, which is robust, to create and to set up a sound message in case you are determined to take this on board. Another element that we have analyzed is how to calculate the CO2 emissions and who is taking the credit by exchanging the flows. And this is extremely difficult. This is, and on top of that, this is a sensitive issue. To be honest, this is a proposal, is far from perfect, but we have set up different ways of thinking who is emitting what after having exchanged flow. And then again, what we have done is to adapt the methodology to the different three lighthouses. They exchange different materials, they exchange different energy flows, they have different environments, then the complexity is quite high. And then we concluded it wasn't useful to standardize the results, and then as a result, we adapted them to the specificities of each of the lighthouses. That's why we have proposed micro, meso, and macro is a way to put it. Is one of the options that we have agreed among us, but it was useful to try to use the same language. Otherwise, we are comparing pears and bananas, and this is completely useless. And on top of that, it must be a misleading message when we say how much CO2 I save. And this is also an important thing. We need to be careful when disseminating what we save in terms of CO2 when talking about industrial symbiosis, because we don't understand the same in all cases. Then also for the sake of promoting the concept of industrial symbiosis, it's important to use the same language. And this is, in our opinion, one good attempt. Again, far from perfect, but still useful. And last but not least, we have also promoted and worked extensively in facilitating the exchange of data in the lighthouses. Also a very controversial and difficult topic, which is the exchange of data, the exchange of information, and why and how. We have developed 3 dashboards, one per lighthouse. We have had a lot of conversations between the developer and the owners of the lighthouses, and we concluded that we needed to understand what is the type of dashboard / platform we need. And this is not easy when launching a project. It takes a while to understand what is the information we need, what is the information we can really get access to. And this is maybe one of the main conclusions, is to understand who is going to use it, when it's going to be used, and what is the real data to be exchanged. To dream is easy and is for free, but the important thing is that the platform is used, not just to have a very nice dashboard. And then, of course, we face different things, different elements that are hampering and also making this process a bit difficult, which is confidentiality, trust and security, that has been also mentioned by some of the previous speakers. And last but not least, as a remark, maybe for the future or for other industrial symbiosis cases, do we need a platform to exchange which data, but in particular, at which state? Do we want to incubate? Do we want to make something to happen? Or do we want to support the implementation of a case that is already agreed? Or we are aiming at monitoring something that is up and running? Those three cases differ completely to the needs we need to implement as part of the platform. Then, just to conclude, few elements, few tools, few methodologies that hopefully are useful not only for us, but also for our larger community. Thank you.
Ignacio, thank you very much. That was great. I like the way you started talking about the facilitator, because it really is a fundamental role. And so it was so good that you, and also the role of data, and it's incredibly complex, you know. Now we have Murat, who's going to be talking. Your title keeps, or
Keeps changing
keeps changing, yeah. Business and contractual models for IS. Maybe it's even,
No, actually changed again because I want to talk the relationship between the bottle and me. Yeah, I'll come back to that in a bit.
Yeah, thank you. I think maybe one extra thing that we need to start re-emphasizing is that there is an industrial symbiosis gap out there, which means that there's a lot of techno-economic possibilities and they are not harvested enough. So the whole point why we are in here is that we are trying to fill that gap in making more industrial symbiosis happen. And there's the technological dimension, where there's some other dimensions as well. And one of which is having the business models. Peter referred to that as having the business case. Business models, you know, I'm an academic, at least my title is so. In practice, it can be questioned, but and the business model is typically defined as a set of activity that goes beyond the firm boundaries, that allows you to create value, but also includes that this value is shared among the people who enable that value. And actually, I would add to that this value is shared in a foreseeable future, not for a day or a week, but in a sustainable fashion. And in industrial symbiosis, that means that there's the element of resource optimization, service sharing, utility sharing. So the business model operates in that way. And if you need to deconstruct it a bit, what that means in industrial symbiosis is that parties choose to operate with a partner, maybe rely on their residual flows, or they try to source their inputs, or they choose to manage their outputs collectively, and in the process realize a bigger transformation, moving from fossil-based to renewable or primary to secondary. And in the process, they forego some other alternatives, which is typically using primary resources or fossil-based resources, etc. And that, of course, is expected to generate certain gains. Typically, we hear that input sourcing cost reduction or waste management cost reduction are important, or some of the byproducts can be turned into income streams. But as we'll come back, it can be much broader than that. A greenhouse operator can actually jump over the capex and gain access to a very massive greenhouse that actually is state of the art. A pulp and paper industry can actually address the permit renewable process because there's a partnership. Or new products can be rolled out for which you can get a premium, etc. But it doesn't stop there. There's also pains associated to that. It's much easier, for sure, to work with the primary resources. Sometimes it can be costly to implement industrial symbiosis. These things are residuals. They tend to fluctuate in their quantity and quality. So that gives a lot of headache to people. So there's also a lot of potential pains. And of course, parties like to be compensated or need to compensate each other. And that very much is based on what these pains and gains are, so that actually compensation can be adjusted. I say compensation because sometimes the waste generator may have to pay the waste taker if their alternative to treat the waste is higher than giving it to that person. So I think compensation is the right word. And of course, all of these things require a lot of knowledge and information exchange to actually assess properly who gains what and what are the bottlenecks and what needs to be done. And here comes the element of safeguarding these things, because of course, parties like to be ensured that these gains are going to be there for a foreseeable future, but their pains are also going to be removed, reduced, or at least managed so that actually they are on the safe ground. If you go back to that, for example, we really established a good relationship with this bottle. It is very obvious how we're going to derive value from each other. I'm going to take very good care of it. It's going to provide me with cold or warm liquids. We established the risks as well, which is confidential. I cannot go into that. We also made some specific investments. I went and bought a carabiner that is actually the matching color, so that will enable this partnership. Kindly hang this. So I think I don't need the quiz. I think, but there is a side. And so what that means is that going back to the gap, industrial symbiosis gap, that of course requires for the actor, and there are a lot of people who do this because there's a lot of operational synergies. But for the new actors, at least we depart from the understanding that there's a knowledge gap, that people may not know these kind of things. And the things that needs to be known, at least these 4 questions. Who gives what to whom and how, what gains and pains are there, who compensates whom for what and how, and what are the terms of engagement. And at the start of the project, when we looked into what the knowledge ecosystem is like, the first one is fairly well known. The information is scattered, but there's a lot of information on what kind of exchanges takes place. There's also a fair bit of information about the pains and the gains, although this is even more scattered, because case by case, people actually pick up different values they generated and different risks that they perceive. Not that much of talk about how the risks are managed. But the compensation and agreement terms, at least in the publicly available information, that was almost non-existent. Of course, the likes of Thomas or Paquita or all the others do these things, and that knowledge resides with them, but that knowledge is not necessarily readily accessible to the rest of the community. So, and the departure point is that this gap is partly explained by this knowledge gap, and that's what we try to fill in this work. And because the existing literature didn't help, we actually turned to practitioners. And we talked to more than 50 people and dived deeper into 70 symbiotic relationships and tried to develop a better understanding about their operational aspects, but also their values and gains or pains and gains. And how did they work about their compensation schemes, as well as what were the terms of engagement. And I think every case that we came across can be the subject of one of these events that we can go into the details and talk quite a lot about it, which we don't have the time for. But if we can just look into different extremes, for example, that we have industrial symbiosis cases which very much resemble market transactions. The technologies are well known, there are multiple partners, the resources can be moved on trucks to different providers, there are known market prices to compare against, etc. And on the other extreme, you are working with resources that were not being used before, such as 45 degrees waste. You need to move things in pipelines. There are multiple actors. There are not market prices to compare against. That requires a much more sophisticated way of dealing with that. And the way we try to make sense of this is that we try to highlight some of the issues. Like if you look into pricing approaches, the literature says, or maybe the practice supports it, that there are 3 different pricing approaches. It's cost-based, it is market-based, and it's value-based. So when we looked into what we saw out there, we realized that in industrial symbiosis practices, it's often a mixture of cost-based and market-based, or finding the middle way between there. whereas the value-based pricing is almost non-existent, which is actually very important for industrial symbiosis applications because someone needs to pay for these softer values. Peter mentioned resilience, for example. Who's going to value and pay for the resilience? Environmental performance. Some of the things are turned into regulation. They can be converted to hard cash. Some things are not. So this was an interesting finding. Another issue is that some people will share the gains needs to be shared equally. Actually, out there, the practitioners don't think so. They are very happy to accept the fact that the one who makes the biggest investment and takes the biggest risk is also eligible for the bigger share of the gains. But so it was a major task. But luckily, we have Mariana that you can throw anything at her, and she comes up with some sort of a solution. So she took that jungle and she said, okay, for the people who need to deal with pricing, there seems to be 13 categories of challenges. And the practice tells us that there are these kind of approaches. So if anybody of you or if someone in your networks is struggling with finding a pricing solution, there's some material that you can go and learn from, and maybe that will help. Linked to the value and gain consideration, it also became clear that there was a need to actually structure what kind of gains and pains can be associated in industrial symbiosis instances so that people can actually more comprehensively look into them, not only in their system, but also for their partners, and collectively decide what the net value from a relationship might be, and use that as a departure point, both for the compensation discussions, but also to understand what kind of risks are there and who needs to do what, who needs what, and so how the terms of engagement can be better profiled. And we also try to put that together, and it's out there for people to make use of as they wish. Coming to the actual agreements, depending on what kind of relationship they are looking into, there are different dimensions, all the way from setting the overall objectives of the partnership to the bits of how the non-conformance situations will be handled, how long the agreement should be valid for, how flexible it will be in light of changing market conditions or operational parameters. And we also try to understand how different actors solve these kind of issues in different contexts, and did two things. One of them was to look into common risks that are likely to arise in industrial symbiosis cases, and actually listing the way that we saw in practice on how the actors actually deal with these kind of risks. And the second item was to say, try to categorize industrial symbiosis relationships into three main categories based on the dependence and integration they entail, and give some starting pointers of what should be considered for the agreements. Because one needs to acknowledge that the agreements can get very complex and very costly. So there's an art in making efficient agreements that are also effective. So the agreements needs to be fit for the purpose at hand. It doesn't really help to overdo it. It actually backfires. So based on the different categorization of the symbiotic relationships, we also try to propose some ideas on what needs to be. How many minutes do I have? I still need to talk about my bottle and my...
You've got 4 minutes.
4 minutes, oh, that's fine. So what happened at the end? We think that that knowledge gap is partially filled, because I think at least the pricing discussions and the agreement terms, there was really a big void. And I think that void is partially filled with the CORALIS deliverables, which you need at least a weekend to read and digest. So they are not very short material, but there's a lot of useful content there. And regarding the impact, we were very lucky to turn this into 3 scientific publications. Hopefully someone somewhere will read it and turn it into action, and the world will be a better place. There's no guarantee of that. And we have been also feeding that into different training initiatives that we are part of. We are at the university, we have students, we have been feeding all this good knowledge to them. So when they become decision makers, hopefully they're going to take these things into consideration. But we also roll out training programs for practitioners, mostly in Sweden, in the Nordic countries, but also within CORALIS for the wider context. And we have also been trying to capacitate the practitioners on how they can take advantage of this kind of knowledge. We did discuss these things in webinars and workshops, in real life workshops, and try to, in the minimum, tell people how others have been solving challenges that they may face. But we are also in the lookout for two things. We are in the lookout for cases that are in development so that this knowledge can be formatively used while they're going through their work. And we are in the lookout for failed cases, because studying successful cases is very much like taking the temperature on the 30th of January and reporting it as a yearly average. So the successful cases have a lot of similarities, whereas we need to look into those cases that failed and understand where they failed and really try to understand whether this knowledge could have made a difference. So if you know of cases that failed, please reach out. If you know of cases where people are actually in the discussion of understanding how they should set out their terms of engagement or pricing, please reach out, because we would like to have a dialogue with those people. And going back to my bottle,
Murat, thank you very much. This was excellent.
I return the bottle for everybody. So
Okay, so we're witness to that. Now, third, we have Roberta, and regulatory issues came up quite a bit this morning, okay?
Yes.
So we're quite happy to hear what you have to say.
Thank you, Rod. Thank you. So just as Rod said, we have already mentioned the regulatory aspects and barriers. So repetitant juvent, we can say Latin, but I try to be brief and try to highlight the main aspect that could be useful also for us of you or our. So the main aspect that we have analyzed in CORALIS are related, as we said, to waste management and reuse, and energy recovery and reuse or distribution. So going briefly to the main directives that are related to these topics, we have the Waste Framework Directive that we already know, and the Renewable Energy Directives. We have also the Energy Efficiency Directive that also support the energy recovery. And we have included all these kind of directives in our analysis, but going fast on this directive, we can say that regarding the industrial symbiosis, through these directives, is important to support the use of renewable sources and also the production or other form of energy through renewable sources, and also to support energy communities, for example, going through the electricity production from, I don't know, for example, one industrial plant to another industrial plant, supporting the energy consumption together. So going to the waste framework is a little bit complicated, because firstly, we can say that this kind of directive set a first waste hierarchy. So the first step is the prevention, so reduce the waste production, or preparing for reuse, so going to on the byproduct definition, or recycling, recovery, and the last step is the disposal. So see, this is the first setting that directive gave us to understand which kind of pathway could be from a waste. The other aspect is related to the targets. So we can say that each company is important for each company to respect this kind of target, not only at local level, but also at the national level. And the third part is that this directive introduced the main criteria of the end of waste. In fact, these kind of criteria are many important in CORALIS. The first criteria is the byproduct identification. So we have here some definition, but the main problem that we have faced in industrial symbiosis is that you can see here 5 points that a byproduct need to respect. So to be a byproduct, we can say product, need to be a substance or object, and we have to make sure the use of it. The second part is that this object need to be used without further processing. I continue to list the points, and after I come back to this second point because it's the most important. The third part is that the subject or the substance object is produced as within the production process of the original, we can say. And the last part is that the substances or product don't have negative impacts on environmental and health. But the second point is the main barrier, because if we take, for example, an industrial plant that produces a product, okay, they don't need that product and they want to sell to another industrial plant as byproduct. But the second industrial plants need to, I don't know, for example, act just a further process to use that product, just to align the standard that they need to respect, or order to need the quality of the product that they need. This kind of treatment is not possible. So if the second industrial plant want to use the waste of the others, is not able, because in the exact moment when the first industrial plant cannot use or put that certain treatment, that product become waste. So I hope to have been clear. And the other problem is at the end of the life of the waste. If some company want to use a product that is identified as waste, it's not possible for it to change the status of waste and become end of waste without respect these 4 points. But another aspect is that if one company want to approach the end of waste process, need to be a certain authorization and be also a waste treatment company. So typically, when we are talking about an industrial symbiosis, it's not so sure to have this kind of authority or authorization to let the waste become end of waste. Going end, based on the brief description that we have made, we can say that both at European and national level, each European country that we have analyzed have introduced the definition of waste hierarchy and also the definition of byproduct and end of waste correctly in their national laws. And also we can say that each country is promoting the energy recovery, energy efficiency, and also the district heating and cogeneration. And we can also say that the main substances are compliant with the REACH regulation. But if we go to the barriers that we have faced in CORALIS, we can list that we have a double face. So, for example, sometimes we have faced the consistency of some regulation. So, for example, for the byproduct, we have seen that in some countries, the steps that is need to take are different at the country level. For Italy and Spain, we have seen different aspects respect to Sweden or Turkey. And another aspects are related to the energy exchange limits. In fact, if we are talking about to thermal recovery and district heating, each country has a different level of development of district heating. So, for example, in Italy and also in Sweden, is in some part of Sweden, if I'm not wrong, is well structured, the infrastructure. But in other area, or for example, also in Spain, the district heating is not so regulated. And also, if we want to speak about the energy selling and distribution, it could be a problem. And after this, we have also a fragmentation, also at regional level. We can say of the different regulation, also for the authorization processes. The last part that I want to show you is the focus on the main barriers related to the demo cases that we have seen this morning. In particular, we have talking about the authorization process also with Daphne. And for example, the more important things is that sometimes if you want to approach within industrial symbiosis to a research plant, the authorization process can be, I don't know, can require 1 or 2 years. But if you want to face an industrial symbiosis at the industrial level, so you want to start to gain money for this kind of plant, in some countries, the authorization process can require also 5 years. So this is the main barriers that we can identify. Also related to Sweden demo cases, for example, at the moment, there are not clear guidelines for the using of CO2 in food production. So maybe many potential demo cases, new plants can face different difficulties without have a correct support from the regulatory. The data sharing also is another aspect, because it's important, the collaboration with the companies, but sometimes it's not possible to share the sensitive data. So this is another aspect that is important to try to facilitate. And another aspect is related to the hydrogen production, as also Janne said this morning, that not only regarding the production, but also regarding the quality, the security. So it's very important to also develop these aspects, not only for the production aspects, but also for the distributions. So going to the conclusion, we can say that at the moment, and also as Peter said this morning, this is the right moment, because we know that new standards were published, and the idea is to integrate the industrial symbiosis in circularity and also sustainability concepts. So after these barriers, the main conclusion that we can say is that it is important to try to facilitate the industrial symbiosis among the regulation, and try to maybe identify and also some specific ITER for the industrial symbiosis development through the different aspects that we have analyzed. Thank you.
Roberta, thank you very much. Now, we've had 3 very good presentations on different aspects of the non-technical barriers or non-technical solutions. I don't want to use the word barriers all the time. Does anybody have a question? I somehow this morning I missed a question, like somebody's hand up. So if you really have a question, a burning question, yell out to me or whatever, you know. But anyway, does anybody have a question? I have one. What I want to know from all 3 of you is, what has been the added value of CORALIS? You talked about, you know, the literature search. Murat, you've been doing this for a long, long time at the academic level. Ignacio, you talked about the facilitator, you talked about the need for data, a number of things. And Roberta, in terms of the regulatory things, what new came to CORALIS because of CORALIS and through CORALIS?
Maybe twofold conclusions. Firstly, within CORALIS, for the demo cases, I think maybe they disagree, but now they think a bit broader than when we started the project. And then I think what we have presented here is an illustration of how much they have thought. Not only for the deployment of what they had in mind before starting, but what can be done, in which way, in a more sustainable and competitive way, and what are the next steps. And this is part of the great value, is not only to have been able to deploy what they wanted, thanks to the financing of the project, but also to cooperate with someone else, many people, as a matter of fact, along the 4 years project. And I do believe this is a very rich result for all of them. And aside from CORALIS, I think we have demonstrated that this is difficult but possible. This is doable. And the final figures at the end of the day can be shown. And this is real. This is not an invention. This is not paperwork. And this is also based on a determination and tools that have been validated, enriched, and deployed, and many lessons learned. Something to be learned needs to come from something that is real and happens. And thanks to CORALIS, we have been able to test and validate and experience things. And this is a great opportunity for all of us.
And as Peter said, in terms of learning, it's the time to be able to send those messages out of those learnings, not just to keep it inside the family.
Indeed, this is maybe one of the conclusions that I wanted to highlight at the very end of the session, but maybe we can just talk about that right away. We have been advertised to just take all of lessons learned and just to use the communication channels to disseminate them. And then we need to think and take advantage of how much information we have stored. And this is not only for our own sake, but also for the future of the framework program, regulatory issues, and also many other aspects that definitely will affect us all.
Barat, I mean, I've seen a lot of your academic papers. What's new that you're bringing to the business model world or whatever from CORALIS?
Yeah, first, I'm sorry for the papers that you had to go through. No, I mean, I think we need to go back to the people in Kallenberg who have done these things for many years and very successful. They said, and they said it in 1970s, I think not many people could relate to that. They said, systems make it possible, people make it happen. And I think at the end of the day, we come to people and people really need to believe in this and they need to support in this, etc. And we are in the business of co-creating and diffusing knowledge that can catalyze the process by reducing the barriers to implementation. So now there is also more knowledge about how the value of industrial symbiosis can be more systemically analyzed in a system perspective, not only for individual actors, but also combining them, which means that people can hopefully be better informed what they can expect to get out from a relationship, but what kind of challenges they may face. And there's at least a portfolio of good practices that are out there. If they are challenged to say, okay, how do you actually make an agreement in a context where there are no market prices and prices tend to fluctuate a lot? We can say, please go and speak to Adven, and they've been dealing with that. And they created a pricing mechanism that is actually based on an index that includes 4 parameters and this and that. So for those who want to do these things, I think now there's going to be a bit more tools available out there that will ease their journey and hopefully also increase their willingness to work with this kind of tool.
But that also means that brings the role of the facilitator becomes all the more important to take some of these issues and to be able to explain it to, because the different companies that are involved all have their own context. Someone's selling waste heat, someone's selling wastewater, someone's buying waste. You know, they still live within little boundaries themselves. They don't often all have that big vision.
That's a very good point. And I think we also need to make the distinction that oftentimes we speak about facilitators as the third parties that try to coordinate between the actors, but there's often also facilitators in the companies. That we call them maybe champions. You know, they need to pick up the idea and they need to show them what the value is. They need to create social capital to mobilize other people. And maybe the part that we have done in this business models, etc. Of course, the external facilitators can also use that. But oftentimes when it comes to pricing negotiations or agreements, the facilitators, the third-party facilitators are usually on the other side of the door. But the internal facilitators perhaps can benefit more from the work that I spoke about. Like what are the do's and don'ts of pricing agreements or the agreements as such? I don't know whether that answers your question.
Well, it does.
Okay.
But, no. Okay, we'll do it right. Well, this is quite interactive.
Yeah, much more related to what you are saying and with your question about fails. Some project that failed. We got some example. Most of them are related to annexes of regulatory standard. Most of them, because, for example, sharing wastewater. If you are sharing water with another company, if there's some problem, who is the responsible of this water? So nobody wants to be responsible. So that is jeopardizing these projects, for example. What do you think about that? It can be a barrier, a big barrier,
Absolutely.
because for us, it was a real barrier that we couldn't go on with the project.
Absolutely. To find to find a solution to things like that is absolutely very important. And actually what we did alongside CORALIS, we also had another project where we looked into the role of specialized actors, which try to make industrial symbiosis happen. Thomas's company is one of them. And they seem to offer a very good solution because they actually try to monetize risk management. If you take your example, they say, we are confident that we can actually deal with the emission situation better than the existing industry. That's why we can assure the regulators that there will not be a spill. And of course, we are going to turn that into a compensation towards the industry. But absolutely, I think when you are talking about incumbents whose main business is not to better utilize the effluents, that is definitely a challenge. And then what needs to happen, I think the regulators also see a broader picture of the risks versus the gains. I mean, this is not only about spills or emitting less to the environment. This might be about preserving the jobs. This might be about improving the innovation capacity in a context, having a transformative change about moving from fossil-based to renewable-based or primary to secondary. And you can also expand that and include the financiers in that domain as well, that the wider group of people need to understand the bigger range of benefits. But I can totally see that it is a game stopper if actors don't want to take that kind of risk. A very long answer to a very simple question. I'm sorry about that.
Nothing is too simple. Roberta, I mean, in terms of looking at the regulatory environment, even you had the 3 demonstrations, you had the 3 followers. Was there some commonality in the issues, the regulatory issues they dealt with, or were some completely different? I know all of the hubs were different sectors, but if there was some commonness in some of the issues that they all faced.
Yes, absolutely. During our analysis, we have conducted separated meetings with each demo and followers. And for sure, we have seen similarities, for example, for the authorization process. So for sure, this is one of the first steps. And the other problem is sometimes related to the wastes, but in CORALIS, the main problem was related just to the Brescia demo cases. Because, for example, for talking to Paquita in their demo, they don't face these problems. But coming to your first questions, for us, the value added from CORALIS is also because during our analysis, we had the chance to analyze so many laws and directives and so many for the selected countries and for the selected real case. So match these regulations with real cases. We have put the real case into the regulation and understand which kind of barrier specifically for that kind of problem. So I think that CORALIS experience guide us to understand a little bit more the regulation aspects.
Thank you. In the next session, when we have our little open panel of non-CORALIS people, we actually will have somebody from Senelec who will be talking about one of the other projects that are funded by the EU that is looking at the regulations in quite a bit of depth.
Can I add something to Paquita's question?
Oh, absolutely.
One other thing that came out is that open and genuine communication is very important, because when you go to the risk management, different actors may have different capacities to manage different risks. And only when you have the very open communication, then you reach to saying, okay, like if you're going to do something with Repsol and if the effluence is a problem, when you reach a certain level of trust and openness, then they may say, oh, we actually have these superb wastewater management folk in here. So we will be better positioned to manage that risk. But of course, it cannot be bulletproof. So we still need to have contingencies and in those cases, we may ask you to pay a bit extra. So that is also quite important to understand who has what to actually deal with the risk and what is the good combination of actually addressing things a bit better. It works slow up here.
No, this is.
Yes,
This is
it's-
fine.
It's very general. What you said is true, but there's another problem. When you are collaborating with a big company, we've been talking about big and small companies. It is here small companies because the big companies, they don't want to be on the title on the head of a newspaper saying that they contaminated or polluted something. So they don't want responsibilities at all. No, they are too big to risk. Too big to risk. That's the point.
We don't really have time to discuss it, but we've talked about the academic world. How a lot of universities teach energy management at the engineering schools or whatever. How do we integrate IS into the? How do we convince them to actually start teaching it? I don't want an answer right now because we're going on to the next session.
Can I to conclude something?
Oh yeah.
Just taking advantage of what you just said, how to teach students, but also how to teach public servants. We need to, we are in a position.
And regulators.
Of course, no, this is what I meant. Of course, we have experience and we have been interacting with public servants along the execution of CORALIS, and many of them, and also from our experience, people say, I'm not ready to assess an industrial symbiosis case. It's so complex, I don't have the skills, I've not been trained. We should also insist on, well, lack of willingness is one thing. Of course, we have the right to complain. This is fair enough. On the other hand, we need to highlight they need more information. They need to be properly trained. And this is very much related to what you just said, how to convince people to know what industrial symbiosis might imply.
If I may, I mean, we have a practitioner training program from Linköping University, also refined and fine-tuned within CORALIS. It's an applied training program that people both learn and work on this. We are happy to diffuse that both on our own right, but also in partnership with the other amplifying organizations. So please reach out, and that seems to address some of the challenges you make. The other element that we need to do, in addition to the universities, is that we need to bring this to vocational schools.
Right.
And we are also trying to work on that on multiple fronts.
One of the next panelists is nodding yes in agreement, so that's good. I would like to thank all three of you, Ignacio, Murat, and Roberto. Thank you so much. There's a slight change to the agenda in the sense that we have left at the end half an hour for Ignacio. He's not taking half an hour, okay? He said where did he leave? Yeah, anyway, he probably will take 5 or 10 minutes just to wrap up. So he said we can take a little bit more time here. We probably won't, but we've got the possibility. I'd like to bring Aurela Schitzer, Sophie Wilmette, Sebastian Vogel, and Akbar Siddiqui up. Aurela is from the Industrial Minerals Association. She's vice president from ASPIRE as well. And she's the director of industrial affairs in Raw. Please sit down. Okay. It's okay. And Sophie is the senior innovation man. We need innovation, so this is great. Of the European Chemical Industry Association, CEFIC, which is, again, the potential for the use of IS is really high in that sector. Akbar Siddiqui, oh, I'm sorry, Miss Sebastian, now he's from Sensenelec, okay? And he works on research and innovation at Sen and Senelec, two of the 3 European standards organizations. He also represents the Risers project, as I mentioned, so little introduction there, where they're developing a standardization roadmap to scale industrial symbiosis across Europe. So we're really looking forward to hearing more about that. Akbar, who was just brought in a couple of days ago, he's working as a product manager at Stamic Carbon. God, I can hardly pronounce it. And he takes innovations to market, strategically overseeing their entire product portfolio to ensure alignment with their strategy and market needs. Markets, strategy, this is very important. Leading strategic planning, product development, market research, and product lifecycle. You probably don't even know what stomach carbon is. It's been at the forefront of developing and licensing technology for the urea industry since 1947. So I didn't know what the company was. So anyway, I've learned that. But all four of them represent non-Coralis work. They haven't been involved, but they've all had quite a bit of background in industrial symbiosis one way or the other. To get them going, I gave them 6 questions. And I said that I would only use 2 of them, probably, because we wouldn't have time. Well, we might have some time. But there could be some surprises from this morning. I don't think there's any surprises. But what I want to hear from them is how we move forward in IS in your own sectors or from what's happening here, and bring out some of the issues, because this is the end of this project, but it's not the end of where we're going. And we heard Peter Hanley this morning in terms of the timing couldn't be more perfect for what we're doing. And so I'm going to ask Arella first, because you were with us yesterday and you heard some of the things we have to say. Oh, yes, sorry. And I'd just like to get your views on how we're doing.
Well, first I'll start with a small little correction. I've been part of Coralis from the very early beginning of the day. I just spoiled.
Nobody told me.
No, but the reason we got involved into Coralis was because for us was very important to really get to understand what industrial symbiosis means in practice. When we sell the concept to our members, they are like, what is this? I know about resource optimization. I know about energy efficiency. They speak to me. I can train people on industrial symbiosis. What is it all about? How does it work in practice? So this was the first driver to jump into the Coralis boat and try to learn a bit, or try to surf the wave of opportunities created by demo cases or by followers, because at the end of the day, it's important to build the case in terms of maturity and see how things are moving forward. So the first reason was learning. The other one is how we link Coralis with policy developments. We heard in the morning so many ongoing policy initiatives: the Clean Industrial Deal, circular economy, waste framework directive revision. So the opportunities or how to tackle the bottlenecks that have been identified as part of the Coralis, we need to be able to feed the political discussions with real demo cases. What we learned, what we actually identified as opportunities, what we identified as possible barriers as well. And in the first session, I stopped to count how many times permitting came up. I stopped at 18. Would have been even more than that. I stopped counting. But this shows a bit that there are recurring issues independently where you are geographically, or what are the sectors that are directly or indirectly concerned. So for us, it was political advocacy, meaningful with concrete examples.
Sophie, I've got a question for you, because I mean, CEFIC is one of the really big industry associations here in Brussels or in Europe. I know over the last couple of years, all the associations have been developing decarbonization roadmaps for 2050, 2040. Does IS ever get mentioned? And how can we embed it better in the decarbonization roadmaps?
Yeah, so it's clear that, well, to start with, as a chemical sector, I mean, to produce chemicals, we need carbon. So we're not talking about decarbonization roadmap, for sure. We do need carbon. We do need different type of carbon. Therefore, this is part of the industrial symbiosis approach. One important thing just for industrial symbiosis and the chemical sector, to make it clear, the concept is kind of inherent to the construction of any chemical site, because it's inherent to the fact that we do have many products. So we start with, bulk chemicals, and then we derive for going to more fine chemicals, polymers, and so on. The big chemical sites have been built with this concept of industrial symbiosis without putting this name. The Germany, they call it the Verbund concept. And this is how the big all chemical sites have been built. So we're using the byproduct from one production unit installation to another one, also optimization of the heat energy flows. Of course, talking about how the chemical industry can go to climate neutrality. This basically enters two major, type of transformation. One is how the technologies needed to integrate alternative energy, sources, alternative energy carriers, and that's where also, industrial symbiosis can play a role. And the other big dimension, I've mentioned before, because we need feedstock, we need alternative circular feedstock. So it's basically how to integrate waste as feedstock, that was mentioned before, how to integrate biomass as feedstock, but also how to integrate CO2 as feedstock. So it was mentioned in terms of reuse of CO2 for greenhouses, but this is also a kind of, carbon resource that can be used, that is already used actually in the case of urea.
Right.
And this is an industrial symbiosis actually between the hydrogen, the ammonia production and urea production. So it's not necessarily mentioned as such in terms of industrial symbiosis. Also, I can say that CEFIC has been working on different aspects, and we're currently working on the circular economy concept, and that's where we see industrial symbiosis playing a big role.
Well, you're a lobby group here in advocacy group, okay?
Yes.
And are you a lobby group? Yes. No, but I'm just wondering how the two of you can help us get some of these messages that Peter says we should be helping to present at the EU level here. You don't have to answer right now. I'll ask Akbar. You're involved in the Initiate program. How different is it from what we're doing? And what have we learned from each other?
Yeah, thank you very much, Rob. Before answering, I would like to I'd like to update you that the last couple of days I was informed that I have to attend this meeting. Then I was not very much aware about the CORALIS project as overall, but then I start deep diving into the project. And today's session is also very important, give me more understanding. After attending today's session, I really appreciate the whole CORALIS team, from the demonstration and from the followers, how they realize these concepts. And there are a lot of challenges. I came to know there are many challenges from economic side, from implementation side, from regulatory compliance, from safety, from implementation, and real support from the local governments. So I really appreciate all of people who involved in CORALIS project, and I wish you all the success in future implementation and exploitation plan for upcoming projects. Okay, coming back to Initiate, this session also, because Initiate first campaign is going to be started very soon in a couple of months. So these kind of learning definitely will helpful for taking in consideration these challenges and these concerns in our first campaign, because we are going to start first campaign in a couple of months. So there are a lot of, I would say, opportunities of learning. If you see overall as a CORALIS Initiate project, I will sum up into very small, because everybody has different understanding of industrial symbiosis. For me also, I would say it is waste to values, how we can convert our waste into values. For example, there are many examples in Fertiberia, in other industries, where they have realized the waste into values. In the same way, Initiate project is basically converting flue gases and capturing the CO2 and getting hydrogen from these flue gases and converting to valuable products. And making because we belongs to STEMI Carbon, and STEMI Carbon is basically world leader in urea production, and urea is considered as not very environment friendly because of the CO2 emission. So how we can make neutral urea? So this is a very nice example where we don't need any extra CO2 from the burning the fossil fuels. We can capture the CO2 already emitted into the atmosphere and convert into the urea production. So these kind of, and on the other side, I was listening about Pakita about how we can see, first, we need to focus on the neighboring industrial symbiosis, but we can also see from the outside, because there are some relation between, let's say, something we can do internal, but there are some byproducts which we produce may be useful for other industries, or how we can, outside the box, we can see these relationship between industry to industries. So I really appreciate about your achievement and your resilience and your commitment towards realization of these demonstration.
Thank you very much. Sebastian, you're involved in the Risers project, but you're also with Senelec. You also, when at the coffee, we're talking about bottom up, top down, and but we won't talk about that right now. But I'd like to just know how the Risers project and this project have any connection.
Yeah. I think first of all, like Risers is about generally mainstreaming industrial symbiosis, and the tool that we use for that is standardization. Maybe to start with, like I think in general, any industrial symbiosis solution needs to be like easy accessible, it needs to be trustworthy, and then we have to make it replicable. So easy to implement. And how do we do that? We create manuals for other people to exactly follow steps and learn from other people, knowledge sharing. And that's basically what a standard is. It is a manual for other people to follow. And that's also what we create at Senelec, manuals for all kinds of activities. Within the Risers project, we actually identified, I think, about 350 technical committees that we coordinate at Senelec that are relevant to industrial symbiosis. So it's a huge community. And just like to put it in perspective, there's different estimates, but we have about 100,000 experts working on standards. And a majority of technical committees is actually relevant to industrial symbiosis. So what are we doing in the Risers project? We, of course, have the regulatory aspect, and then we have the standardization aspect. And I think there's also a lot about education as well. I would like to separate this regulatory discussion that we're having from the standardization discussion. Yeah. And I saw, yes, I will. I saw on the last slide that EU directives somehow say what standards there are. This is only partially true. The majority of standards, the vast majority of standards are really industry driven, and all standards are created by industry. So we, as everyone here in the project, all demonstrators, implementers, practitioners, everyone can create a standard. And this doesn't have to have any relation to EU legislation, not at all. But then we can link it to legislation. And I think that's where the magic happens, and where you can also show compliance with regulation, where you also like in the end get easier investments, etc., because you have this proof of conformity. But I think I would separate this. And when we talk about legislation, we have to make changes, of course, and that's something that we discuss in the Risers project, the End of Waste Directive. How could we change it to make it work with standards, with industry, to make it easier for more stakeholders, also cross-sectoral, to work with it. But on the other side, we look at, for instance, steel, slag, textiles, batteries, waste heat. How can we create vertical standards for industry to create manuals that other people can work with it? In a nutshell, I would just like to invite everyone as well to join our working groups in Risers, which we will launch on the 28th of May, so very soon. It's a kickoff meeting, but you can also join later. where we want to discuss exactly this. Where do we have gaps? Where are opportunities? And where do we need standardization? Maybe where do we need regulation? And this we want to feed into a roadmap to then also present to policymakers.
And when do you plan to do that? And how long a process is that going to be?
So now this public consultation phase is for this year, kickoff meeting 28th. Then we have about 10 working groups. You can join different ones, like vertical ones, but also horizontal ones, like ICT platforms we heard earlier, end of waste, industrial symbiosis in general, like what is it? How do we define it? We plan about 3 workshops per working group, 2 before summer, 1 after. It's like half a day each. It's not too much. It's manageable. And then we have an actual plenary at the end of the year where we present the results.
Very good. Oh, yes, Aurelia.
Thank you, Sebastian, for showing us some magic, how it happens. But if we go to the rule of law within the European law, the authorities are bound to follow the rule of law. So what the directive says or how that is transposed nationally, this is what is legally binding for them. So if the law says, if you classify something as a waste, is a waste. And just to give you a very practical example, the Critical Raw Materials Act, Article 27, it says you have to do an economic assessment of your mining waste to see what critical raw materials you can actually extract out of it. Once you have classified something as a waste, you basically cannot touch it anymore. You need a new permit to go to that waste and to be able to make value out of it. Within the existing environmental permit, you are not allowed. You have some flexibility if you have defined it as a byproduct and the authority has agreed to that. But if it is a waste, you can basically not do much about it. So maybe we need to find some common solutions in the gray zone area on the waste or on the byproducts, rather than the waste per se, as the law it is right now, is something you cannot do in the existing permit, or you go for a new permit and you don't know where you end up or how you end up, or somebody else will need to come to valorize your waste, maybe on site or maybe off site. That's something to be defined. But on the legal basis, the authority is legally bound by the rule of law. The standards, they can help, but legally, there are different ways to it. And I don't want to be controversial, but I want to be practical. I want to share how things work on the ground, at least from our experience. But if you have some magic to share, I would be more than happy to join the magic club and see how magic works in practice.
Sophie is ready to, she wants to jump in here.
Yeah.
Okay.
Yes, and indeed, I mean, the waste directive is, as mentioned before, also a challenge for the chemical sector because of chemical recycling technologies being developed, but challenges for deployment. I can give an additional example, is the one of utilization of CO2 captured from industrial installation, from ETS installation, that can be used as feedstock.
Okay.
Technically feasible. However, with the current regulation, the CO2 that is captured from an ETS installation is considered as emitted. And so the owner of the installation has to pay for ETS allowances.
So where does that get changed? If in fact you say this needs to be changed, who's going to do it?
So it's very slow process.
Do you go to JRC? I mean, where do you go?
It's a discussion for a decade. I mean, in the last revision of the ETS regulation, the proposal from the Commission was almost there. However, I mean, in the development of the regulation, some specific elements have been added, which result that currently it's only CO2 that would be used for CO2 mineralization.
Right.
Where the CO2, well, not the CO2, but the carbon and will remain, I mean, permanently bounded in the product.
Right.
But there is, so that's the only case that is solved now. But for chemicals and polymers, we're still where we were 10 years ago.
I mean, you're a big association and you're still getting nowhere.
It's a very slow process, a very iterative process. And yeah, I just get the example in the proposal.
Okay, well, but and then Sebastian, but then we have to get Akbar into this as well. You've got something to say on this, I know.
I think in the moment the laws were drafted, the intention was different. It was to actually avoid waste.
Right.
However, there are parts of the waste you cannot basically avoid. And you have the options are you have a process, you have your intended product, you have a transitional product, which is a byproduct, and then you have the waste. This is how the law is made right now. And in order to change that, you need to basically change the fundamentals of the law. And that you cannot do it nor with the GRC, it is a trilogue process. So the Commission need to bring a proposal forward. The Parliament needs to get involved, the Member States needs to get involved. And they know that there are issues with the transposition of these directives into national law. It is not equally transposed. And even within the same country, you mentioned the steel slag. Steel slag produced from the same, exactly, fundamentally the same process. Northern Italy and south of Italy is classified differently because classification is at regional level. So Italy is actually split in half. The same way south is classified as a byproduct, north is a waste. You cannot actually transport it within Italy. Imagine to cross the Italian border. So these are issues that have been identified, and there are a lot of political discussions how to try to fix it. But you cannot fix it practically. You need to change the law in order to find the solution.
You can't just leave it to politicians. This is quite technical. So there's going to be a technical solution that people agree on.
But politicians will make a politicians do political deals. Politicians do political deals.
Yeah.
They don't mind about technicalities. Technicalities need to be sorted out when the transposition take place or implementation take place. So for politicians, they can consider technical solution, but their main goal is the political agreement and how the political agreement is meeting political agenda. Technicalities, they are sorted at another level and will not find technical solutions at a political level. This, at least to my knowledge, that magic hasn't happened yet.
No. I mean the discussion about legislation is absolutely necessary. That's also why we want to have this working group about end of waste specifically. And because end of waste criteria is something that needs to be discussed, that needs to be changed, and where we also think that standards could support criteria. But these standards need to be developed, and we don't have to wait for the legislation to create the technical specificalities. And that's where I say that we should come together and start from both approaches. We should tackle the political side at the same time as we tackle the standardization, the technical bottom-up side. And maybe to come back to the demonstrations, like you've shown like really successful outcomes here, like you've achieved something. And I think other people should be able to also capitalize on this as well. Exploitation is in the title of this panel as well. And I think there it's really important to also standardize what's possible within the regulatory framework that we currently have. We still need to have a discussion, but we also have to talk about what's possible with today's framework. And I think there's a lot to actually achieve.
Akbar, is the Initiate project dealing with some of these issues?
Initiate project is basically is not a solid waste. We are treating flue gases from the steel industry, which contains CO, which is also very harmful. And on top of that, hydrogen is valuable, you can say, gas. So it's not solid waste. We are talking about the flue gases, and we just recover and convert first conversion of CO2 into CO2, then capturing the whole CO2 and treatment of capturing the CO2 and then separating the hydrogen out of that, and then producing the ammonia from this. So it's, coming back to that, yes, there are some challenges from the legislation and the industrial practices. So how we can bridge the gap, because yes, there are some challenges, keeping in view the evolving situation from the energy prices and from the regulatory compliance, how we can make industry sustainable for the long-term running, because particularly in Europe, energy prices are very high. So I saw some of the industries are closing because of the energy crisis or energy prices. So we need to understand both scenarios, that how we can survive our industry, give them some leverage on some sort of different definition of waste, how they can make industrial symbiosis. I think this is very important for European industries. If we will only, I think there is, we have discussion, I think many people touch this point also, that there is a gap between legislation and industrial people, how we can bridge this gap with engagement, with collaboration, understanding the survival of industry, and how we can fulfill the requirement in the long term. Because now there are transition going on from gray to blue, blue to green, because still there are uncertainties, which these uncertainty has to be considered, well taken by the politician or by the policy makers to keep our European industry keep in survival mode. Otherwise, definitely there will be a lot of challenges. We are seeing many industries are closing. We need to be very careful in job security and people, and from the food security point of view also. These things, I think we need to make a balance out how we can reach into the agreement, keeping industry running and policymaker also to understand each other.
From the issues you've raised, are there new standards that are needed? I go back to 2002, 2004, when the buildings directive was first approved. There is a framework directive. I think that they actually created through Senelec something like 34 standards. And the industry said, we don't have the money for this. And so the commission, I think, gave 25 million euros to the Senelec family to actually get these standards developed. Now, they were voluntary standards. Not every member state took them up. Okay? And even when they revised the buildings directive in 2010 and then 2018, there was new standards that come up through Senelec. Does this happen, or is this needed for some of the issues you've just been raising?
I want to add on to again the point for if you're seeing this green initiatives, we were hearing a lot of last couple of years, people are taking green initiative, but now realizing the economic viability of these green initiatives are not very viable. That is why most of the green initiatives are rolling back. So without strong incentive from the government, these on large scale, green initiatives are not viable at this moment. But definitely in the long term, we will have more solution, more knowledge, more innovation, which can bring this gap. But for example, let's say CBAM implications. Now I belongs to fertilizer industry, so I know if I make ammonia out of green resources, the cost of ammonia would be around $1,300 per ton. If I will keep in view the CBAM implications, I will pay the penalty also. I will not cross the $800. So I'm ready to pay the penalty, but I'm not ready to go for green initiatives because it is not economical viable at this stage, at least. There are still development going on. So there are some challenges. We need to really understand how we are moving towards green initiatives, and all things need to be considered. So this is from myself.
Sophie, are these issues that come up in your industry?
Definitely, I think, and I think that the way the result of the project were very well structured, because indeed there is the technical aspect and what is technically feasible. And but then, I mean, as mentioned, I mean, companies to invest need to have a business case. So, and effectively, a business model in the case of multiple stakeholder involvement with industrial symbiosis. But this is a real challenge. So, this is the economic viability of the implementation of new technologies, and that's the major, the major hurdle, in terms of decision to go to such investment.
I want to ask you.
Okay.
To both Akbar and maybe Songs. What is the share of fertilizer cost in a kilo of tomatoes we buy, or a
kilo of vegetables you buy typically?
The production cost depend because there are depends on the energy resource. I'm talking about first fertilizer cost per ton of production cost of, let's say, ammonium. So it's depend on regional basis. Let's say in Europe, we are in our energy prices cannot be compared with the other side of the region because.
Sorry to interrupt, but I mean the final product.
Yeah.
When the fertilizer goes to a ton of wheat or a ton of tomato, so how much is it? The point is, I mean, we are talking a lot about industry's responsibility. But for example, apparently, if you buy a car, the difference that the green steel makes is trivial. It's like 300 or a couple of euros. So, I mean, is there also a bit of a consumer responsibility that is the tomato price only increase 3% if you are using the expensive green fertilizer?
We've only got a few minutes left, so, but no problem.
But maybe
Yeah.
we are producing green fertilizers and we are producing gray fertilizers. Green is more than double price than gray, more than double. Even we have some advantages in Spain to produce them. So I don't think about the rest of the European factories or companies, but it's more than 20% of the cost. So if you are pushing for green fertilizers in Europe, you will have many problems with farmers, for sure.
Okay, Arella. Okay.
Take on your question about the development of the standards, the number of standards. So as I mentioned, rule of law is first, whether a directive or a regulation, that will be the first for the enforcing authorities. And then standards, in my view, they'll be complementing the rule of law, but it will never be the other way around. So you might have a standard when you don't have a law and they will take priority, but the order or the sequence of enforcement will be the law, and then there will be the standards which they will complement or clarify the law or areas of the law which are in the gray zone. I'll use the gray zone.
The one standard that bothers me in terms of IS is the standard for an energy audit. Because it's just the boundary of a factory. It doesn't go outside the factory. It doesn't look at the possibilities that there's potential. Your neighbor might have something that would actually reduce your whatever or improve. And it's very difficult, but we haven't got into that mindset at all to look outside the factory boundary.
Because I mean, as an operator, you are accountable what's happening within the limits of your operation.
Exactly.
And these are all, so everything related to industrial symbiosis, these are new models which we are creating knowledge right now.
Exactly.
And in order to actually expand the boundaries, there are some legal barriers which need to be addressed. There might be some financial benefits or losses or whatever we want to call it, but it is about accountability. Right. So it makes sense that the way the standards is drafted right now is limited to the boundaries of your system. But if in the future you'd like to expand that, and the case of chemical sector is a perfect, because this is how they work within the limits of the boundaries. But if you have a surplus of something, you can sell it outside, but you need to have legal contracts in place and financial ones to make sure that you do it right.
But you could. If you hire an energy audit company, say you don't have to follow that standard. Look at our neighbors. How can we work together? And we haven't got to that point that any company has ever asked for that.
But you as a company are not going to pay the price for the neighbor. So at the end of the day, it's a direct business link. I hire you to do the audit of my site. You do the audit of your site. Beyond, I don't think a chemical company will be.
No, but you could be asking, what can I do with my wastewater or waste heat? You know, how can that fit into it? So you could ask that. You could put some boundaries on that.
But I don't think it's the duty of the auditor to do that. And I think in an industrial symbiosis modus operandi, if I may call it this way, what we are preaching is to think out of your box.
I know.
Is to think out of the boundaries of your system. And this is a systemic change. You have to first understand internally what your flows are, what the possibilities are, convince your teams internally within the company, financing, CEOs, site manager, that there are some opportunities, and then reach out. But in the existing modus operandis, the limits are well defined. And that's maybe also the reason why for permitting authorities, it's very difficult to permit an industrial symbiosis because they do not have a full understanding who is going to be accountable for what, and for them, where to enforce and where are the boundaries of enforcement.
Well, maybe the next IS project should be called Thinking Outside the Box. But Sebastian, he's got the last word, okay?
Because I think that project is called Risers. No, exactly. We have a lot of standards that think in these boxes.
Okay.
And depending on the standard, we can also make references to industrial symbiosis. We can change standards in themselves. But this really depends on the topic and the standard. And then, of course, the link to like laws depending on the case. But I think for that's important to come together and hear opinions, hear voices, and find these standards and change them. That's why we want to have these working groups and this roadmap to actually make change from the standardization side.
Thank you very much. Everybody, please give them a hand. This was a very good discussion. Look, on behalf, I mean, EEIP was the host. Yesterday, for those at the General Assembly, we were at our building, and we're just one of the 29 partners, but it's been a real thrill to have being able to host this final event. And I hope you enjoyed it as much as I want to thank my team here. You know, I mean, Claire has done so much to make this a go. Where are the others anyway? Well, they're outside. They're still working. Okay, so we've got a good work relationship, but it's been really, really great. And I mean, a lot of you only ever met me yesterday, and but I mean, I've been in and out of the project since the very beginning. So that's the way it goes. But I'd like to give the final word to Ignacio, who has been the project coordinator for this, and who's slogged through this great project. And we've heard some nice words from people who aren't with CORALIS, and they've even said nice words to us. And so, but I think we've had some really good discussion today. I mean, all of the panels were really excellent. Ignacio, please. Oh, there he is. I can't see with these lights.
Well, I don't have much to say. First of all, the project is coming to an end, but it's not finished. There is stay tuned, right? We have paper to fill in, first of all. Don't forget about that. We have still a couple of months ahead, first of all. Secondly, well, the messages that we have received today, I think, are positive, promising, and also, to some extent, some people are waiting for our input. And I think it's worth thinking how to disseminate, communicate, exploit what we have produced within CORALIS. We need to think about that. Thirdly, there are a few things that I've heard from today, but also from yesterday. The demo cases have faced many technical difficulties, and maybe this is for the initiative project. Many technical difficulties, they overcome them all, and then I think we are very proud of showing 3 very different and challenging cases to be showcased from now on. But all of them have also faced non-technical issues. And then this is also something I think we have progressed quite a lot in just drawing the attention on some elements that are complementary but equally important when defining a business case, a technological deployment, and potentially new agreements. Then this is also something that we don't need to take for granted is important. And I think this mixture of non-technical and technical makes Coralis quite unique. And I think we need to, well, as we have been saying so far, be quite proud of. And last but not least, I think we have created kind of a momentum among us. We know each other quite well, for good or bad. It depends on the opinion. But I think it's been a great opportunity for all of us to work together. Thank you so much for your hard work, and see you around. Thank you very much.